Good morning. Welcome to the second day of our International Symposium, PRIOCHEM 2025, the 21st edition. Before going into the plenary session, I would like to invite you all in the coffee breaks and during the lunch break to visit the stands of our sponsors and the exhibitors, as well as the posters. All posters are displayed throughout the day in the ground floor lobby. So the first invited speaker for today, it's a very close friend of our institute, Professor Anton Ficai. Anton is a full professor and PhD advisor in the Faculty of Chemical Engineering and Biotechnologies, National University of Science and Technology, Polytechnica Bucharest, being actively involved in both academic and scientific life of the university. His major academic interests are related to composite materials for medicine, nanobiomaterials for tissue engineering, and drug delivery systems. The research interests are, however, much broader, having the chemical approaches in the center and cover the following topics: tissue engineering, drug delivery systems, multifunctional materials, composite materials, coatings, antimicrobial and antitumoral materials, nanoparticle synthesis and characterization, surface modification, and many others. Until now, over 370 scientific papers, from which over 330 papers indexed in the Clarivate database, and 24 books or chapters, including 3 edited books, were published, along with 28 patent applications, 10 of them being already granted. Valedictorian of Polytechnica of Bucharest, former participant and laureate of the National Chemistry Olympiads. He was awarded with over 150 gold medals, special awards or best paper awards, and more recently he was awarded with the special award for transfer of the research results into economy during the first edition of the Gala Cercetării Românești. Let's call it like that because we all know what it's about. He's also a full member of the Academy of Romanian Scientists and several professional societies. And I want to thank you once again for being together with us whenever we invite you. We highly appreciate your friendship, and it's not a very big secret that we are working together and with, I think, with very good results. This morning, Anton will present his experience in the area of mesoporous silica as an emerging active material for future applications. Anton, please, you have the floor.
So I will take the opportunity to thank to ICECHIM, to Radu and Dr. Mihaela Doni for the invitation to be here. It's a pleasure for me and an honor also. And of course, I'm coming all the time very happy to this institution. Doesn't matter if we are talking about a conference or collaborations on different topics. And indeed, we had the opportunity to collaborate with ICECHIM, and most important, we hope to collaborate in the future too. So with this, I think we can see already on the screen. Thank you.
Thank you. If there are not any more questions from the room or from online, I want to thank you once again and congratulate you. And the selectivity, especially for the heavy metals, is very nice. Yes. We'll speak about it later, but now I would like to
thank you very much.
Thank you once again, Anton. I would like to pass the microphone to our director.
Thank you very much. So the next speaker, it is in fact an invited lecture, which will be presented by Mrs. Mădălina-Elena Argăseală from Romanian from ProHealth cluster. Mădălina has over 20 years of experience in drafting and implementing project proposals. She has been active in quadruple helix medical and bioeconomy ecosystem since 2011 and has been involved in international projects since 2009. She has also experience in strengthening institutional capacities, developing public policies, organizing economic missions, and supporting the development of startups and spin-offs. Her expertise covers multiple fields of interest, such as the development of socioeconomic research methodologies, collection and analysis of qualitative and quantitative data, cost-effectiveness analysis, cost-benefit analysis, public policy design in health sector, and also the development of community programs for health prevention. We thank you very much for your kind presence here, and we wait to find about European funding opportunities in the bioeconomy and beyond, insights and success stories. Thank you very much.
Okay. Thank you very much for the invitation. After the presentation of Professor Ficai, where the presentation was so scientific for me, but it's very close related to what I'm going to present you for now on. I don't know if you already know about the fact that the draft for Horizon 2026-2027 was already published. If you don't know, I will present it today. And I think you can find some opportunities for developing research projects and not only. And as Professor Ficai mentioned, there are still open questions related to the previous research carried by his students. So maybe he can apply to go further with research of the topics presented before. So what my presentation will be very practical. It's a practical presentation. I come from a practical field. As Mrs. Doni mentioned, I write projects for over 20 years. Now we are having in our cluster 7 Horizon projects in implementation. We coordinate an EU4Health program, so we have a lot of experience. So I will go very quickly through all the opportunities I identified for bioeconomy domain, but after that, we can have a practical discussion on how we can prepare a good proposal and a success proposal for us. So we are focusing on opportunities expected in 2026, relevant to the bioeconomy and adjacent areas. Each slide will present what are the funds, who can apply, funding logic, timeline, cues, partnering tips, and also what as a tip, always verify final topics and deadlines on the EU funding and tenders portal before submitting, because as I mentioned to you, the draft program for bioeconomy was already published, but it can suffer some small modification when the final program will be published. So, as I mentioned, for bioeconomy and natural resources, agriculture, and environment, in Horizon Europe, these topics are covered by Cluster 6. What Horizon Europe funds, maybe you know, maybe some of you are new in this field, like the PhD students. So there are 3 types of projects: research innovation actions, innovation action, and support action. So as you see here, we have for RIA projects, research innovation action, we have 100% eligible costs. Innovation actions is up to 70%, and the support action are 100%. In general, when you prepare a project proposal, you need to focus on the partners, but you need to include end users. For example, in this area, you need to include farmers, cities, SMEs, and data validation sites to strengthen the impact. It's very important when you develop a project proposal to have in mind all the stakeholders for the project. And it's important for for example, also to include in your project proposal the aspects related to social and socio-human sciences. Here I prepared it like a technology readiness level cheat sheet by action type, because when you start to prepare these projects, you need to have in mind what technology readiness level, maturity, your idea is, or your product or your concept. Because if research and innovation actions, the project starts at TRL 3 and you have to, until the end of the project, to get to the TRL 5. In innovation action, you need to go behind this TRL 5. So you start at TRL 5 and you need to go to TRL 8 or TRL 9. But it's important to know very well where is your product, at what maturity level is when you start your project proposal writing. Innovation action, sorry, it's, I don't know if it's very well on the green, yellow, green background. So innovation action, it's more ready to be ready to market. So it's 7, 8 or 7, 9. I'm sorry for the first part. It's so research innovation action is until the TRL 6. Coordination support action, you don't need to have a TRL. These are activities which supports the networks, the area, through different activities which are more oriented in capacity building, trainings, and so on. But we also have different, for example, we also have co-found projects, but these kind of projects are action at the national level. So, for example, if our National Agency for Research and Development, UFICDI, they join to different projects at European level, and after they get the finance, they use like a cascade funding for supporting other project proposals. Is not AEC Accelerator is not dedicated to public organization, but maybe in the room or on the line there are some private beneficiaries. Is more dedicated to the private sector, but they also can cover this subject of bioeconomy. So some key points. I think it's important to know that these projects, Horizon Europe projects, are very competitive. And since now we have also the help of AI, I don't know if you read the news that at the previous call, which ended now in September, the number of project proposals increased by 80% than the last time. So a lot of projects were submitted, and it's a big competition, having in mind that for each call, in general, they finance only 1 or 2 projects. So now you need, from the scientific point of view, to come with unique points, because there are also other organizations which don't have your scientific background, and using ChatGPT or other programs like this, they can get funds. So in general, under research and innovation action, a project is around 5 to 7 million. We have 1 to 2 projects per topic. Innovation action, it's around 7.5 million, and often it's there are 2 projects financed per topic. As you see, the support action are smaller projects, and there are between 2 and 3 million euros, and they finance just 1 project per topic. These figures are calculated based on the Cluster 6 2026 draft table. So it's based on what will happen now from 2026. It's written small, but I wanted to tell you that according to this draft program, the first call for proposal will be open in January 8th, and the deadline will be in March on March 10. What is important when you start to prepare your project proposal? Don't wait. Don't wait the final work program. Start now, because it takes time to build the partnership, to find the right partners. It's important to draft your concept. You need to take in consideration also the fact that during December and January, in general, people are on holidays. And what I saw from my experience, even now, we are preparing 5 projects for submission for November 12. And all the projects, the partnerships and discussions started just 1 month ago. And believe me, now when we have 5 project proposals in drafting, it's crazy to receive a lot of emails, to give feedback, to participate in different meetings, and to separate your mind because there are different subjects. So my recommendation, my sincere recommendation for you is to start from now. And another recommendation is during the drafting of your project proposal, when you are ready around 60%, 70%, you already drafted your project proposal, talk with your national contact point. I really recommend to use that. I saw that in Romania, people avoid to go to discuss with the national contact point. But from my experience in other projects where we are just partners, this kind of discussion took place. And I noticed that that kind of project proposal were accepted because they received,
Because our national contact point then has a word to say when the selection will be done?
No, they can guide you better if you, for example, if you really cover the topics of the call. They can guide you because they have a lot of experience, and they can guide you how to approach some parts. Because, for example, from our experience, when you open the funding and tenders portal and you read the call, in general, the call starts with the scope. My recommendation is not to start with the scope. My recommendation is start to expected outcomes. Because when you write a project proposal, you need to answer to the expected outcomes. And you need to think, for example, I had a lot of discussion with our partners. There are some words. They're like mandatory. All the expected outcomes are mandatory. If all expected outcomes are mandatory, then you need to map these expected outcomes in work packages, for example. This is a tip and trick which I use in a drafting project proposal. When I write a project proposal, I write the project proposal through the eyes of the evaluator, because the evaluators have very clear criteria. So they, even if in this kind of horizon projects, we know there are 3 criteria: excellence, impact, and So, but it's important, for example, I have this expected outcome. For first expected outcome, I need to have a work package dedicated for that work expected outcome. So you need to work like this, because it will be very easy for the evaluator to see that you give the match between expected outcomes and your results. Another tip and trick, for example, what I recommend to you, is not to use a lot of specific objectives. Try to establish the specific objectives related to the work packages. Now, if you know about the fact that they change a little bit also the way they give the finance. So we have call for proposal with real costs, and we have call for proposal with lump sum. It's a tricky part when we are hearing lump sum, because that means they will give you the money when you achieved the results you mentioned in the project proposal. So when you write a project proposal, don't write just based on the topics. You need to read also the grant agreement, because in the grant agreement, they mention, for example, when you need to submit the intermediary reports. So you need to think about it. Okay, if I need to submit the intermediary report on month 18, sometimes you can negotiate with them, but it's very hard to negotiate the other intermediary reports, but it's possible. So you need to think about it. Okay, I need to finish to have some work packages ended in month 8 to be able to recover or to receive my interim payment for what I delivered. So it's very important when you put your work packages on the Gantt chart to think about also about the finance.
But we don't have the advanced payment?
Yes, you have advanced. But for example, you have advanced and it's the advance it's big, deep, but depends. But depends on the call, because for some calls, for example, you have 50%. For the other calls, you have 70%. But when you do the interim report, they, according to the grant agreement, they will give you the money, the difference, until you receive, you get a saving of 90%. So you'll have money cash for the cash flow. When in the partnership, there are partners from SMEs, for example, under Innovation Action, where they need to bring from home 30%. These kind of things are very important for them, for the cash flow. For sometimes, for example, you don't receive all the money, because if you have in your partnership some organization which don't have a good financial capacity, they will keep 5% as a mutual insurance. So even if you, according to the grant agreement, it is mentioned that you'll receive 50%, in reality, you'll receive only 45%. So these are tips and tricks from my experience in drafting project proposal and implementing project proposal, because it's very hard to have in mind all these kind of aspects since you start to develop the project proposal. So this is why it's good for you to have in your team also someone from the financial department, because even if we talk about lump sums, for example, you need to give them some insights about how you structured your costs. Even when you submit your financial reports, they don't take into consideration your first this breakdown of the costs, which was submitted when you submitted your project proposal. But they take into consideration. I don't know if you know that there is a database on funding and tenders with the average salaries used for a long period of time. So yeah, you know, you have experience, that's good. But the idea is to share with also with the others, because it's important to know about this. And it's good to put the person month's salary around the figures which are mentioned there. For us, for example, for Romania, sometimes if they have in partnership also private companies and their person months is higher than the average, or they ask, okay, give me some justification for this, or tell me what are the salaries according to your national research and development law and things like that. We had this kind of question. So we already know what we expect from the European Commission when we are preparing the grant agreement. So I will give you more tips and tricks. If you have questions, I will answer you like until now.
I want to ask you about the salaries. If it's recognized our national law part of the national plan with that orally.
Yes, if you are a public research institute, public university, they take into consideration our national law.
50
euros per, yeah.
Yes, for director responsible or
they take this into consideration. Now I don't know, for example, how it works in your public research institution, because for example, what I recommend in general for private partners is to keep for the audit piece, to keep things separately. So for example, I work as an expert in 5 projects, because I coordinate them from the partner, so it's a little bit tough. And I have 5 working agreements. And believe me, it's very hard to keep track on timesheets for each project and so on. But it's if an audit comes, if you have project-based working agreements, they will check only that agreements. So from the point of view of also of the implementation phase, and to keep very clear the record tracks and so on, this is my recommendation. I don't know if it's the same. The public institution can.
It's rather difficult to have 5.
But
yes.
Okay.
Yes, but it's not really.
Yeah.
Depends.
Yeah. Okay. What I want to add, for example, when you build your partnership, you can't cover all the aspects. So you are more focused on the research part. So first of all, you need to be focused on that part. Okay, I will do. Okay, on that part. But you need to bring us alongside with you someone specialized in communication, dissemination, and exploitation to be very good, to promote your project, to connect with other projects. And sometimes people don't put enough money for traveling, to present the project in different events and so on. Please put money on this. Because it's okay. Then another thing, exploitation. We are carrying out a lot of projects, research projects. But from my experience in Romania, is the fact that we don't exploit at the end of the project what we obtained. So it's very important when you start the project proposal, think about also to the intellectual property rights. How we'll share it between you. Sometimes when you sign the consortium agreement or there is an annex with the IPR rights, and some people don't read them carefully. It's very important. I saw that now we are finishing a project and we started the discussion about the exploitation. But what I saw is that we, the Romanians, we are not so oriented for how to exploit our results, because we work a lot in our projects. So I was thinking now of what Mr. Ficai presented, and I already identified an opportunity for this kind of fingerprint. And okay, we can go maybe on bioeconomy cluster, maybe not on biomaterials, but maybe you can go with our project or with our idea in a project related to civil protection. cross-border protection, because, okay, I developed something, and now I need to test, to demonstrate if what I developed, it's okay or not. So there, a professor of mine 20 years ago, he said to us, to his students, you know, around us, it rains with opportunities, but only few people knew or have the ability to identify these opportunities. So I'll go very, very fast. Sorry for this. So there are a lot of opportunities now. Please read this work program. If you don't have it, I will send it to Mrs. Doni and can share the draft program with you. Okay, so as you see, there are a lot of them. I will not go through each of them because I also have another funds to present to you. So what I saw in the last few calls for proposal, this word, co-create, co-design, it's very fancy. It's very fancy. But I have to tell you that it really works. It really works. And it's very important to mention in your project that you'll co-create, co-design what all of your deliverables, all of your action together with the stakeholders. So it's important to involve them from the beginning, because it will be very hard during, if you don't work with them, it will be very hard at the end to sell what you produced in your project. So you need also to plan knowledge exchange. So this is the reason why I said to you, put money for travels in your budget, because knowledge exchange, even now, okay, so there are some people in online environment, but when you take the break, you can continue the discussion and you can establish some partnership. And it's very important to establish connection, personal connection. It's very important, because if you establish a personal connection, it will be much easier to connect with the organization from where that person comes and so on. And they will remember you, because it's see you in person. It's so okay. I don't know if you participated in competition on WIDERA, widening participation, strengthening the era. These kind of projects are not related to research itself, but it's more oriented for talents, to host secondments, to assure the exchange of knowledge between different countries. And their main scope is to boost the capacity and the excellence of the research institution. Now we have in implementation 3 projects under WIDERA. Here, as you see, it's not necessary to have a technology readiness level. It's more about support action, and you need to assure the talent circulation. In one of the projects, we are partners with polytechnical universities. So we are working with different universities, also Babeș-Bolyai, and not only. EU mission. Did you try to apply on EU mission until now? And it was successful? Okay. So, okay. Yeah. Okay, another thing related to the partnership, it's very important, the coordinator. It's important when you select the coordinator, depending on the subject. But in general, when we are discussing about research projects, the coordinator is important. We have this EU mission, a soil deal for Europe, restore our ocean and waters by 2030. I already identify a possible project for Romania in Danube Basin. If you are interested, to give you the subject topic. Circular bio-based Europe joint program. I think you already know this. It's yeah, that's very good. European Innovation Council, Pathfinder Transition and Accelerator. This fund is more dedicated to private organization, but you know, also private organization needs to work with research institutes. So even if you can't be the principal applicant, you can provide services for them. Life, in general, this has a funding rate smaller, so your own contribution is bigger, and it's dedicated to public authorities, more to public authorities, because the idea is to have a national coverage. Innovation Fund for Industrial Decarbonization, another fund. These are small projects just with 2-3 entities. And I try to give you also some practical next steps. When you go through the work program, try to shortlist that work program to 2 or 3 topics. Map your TRL fit with and pilots demos you can host during 2026, 2029. As you know, for example, if the project will be submitted in March, you will have the results in general in September. You'll start the process for grant agreement preparation, and this takes around 5 months, 6, depends. Because when you submit the project proposal, for example, it's not necessary that all the partners to be validated in the system. Sometimes they are just declared. They obtain the PIC code, and you can add them in your project proposal, but they are not validated. In general, the partners are validated after they receive for the first time their funds. And it takes a lot because they are requesting a lot of documents regarding legal representative, type of organization, financial accounts, and so on. Us, for example, because we are already validated, we are doing the update of our financial documents each year in order to avoid this kind of verification when we enter in another grant agreement preparation. Assemble like a matrix. So try to identify all the partners, to identify the partners with experience in data management. I think you know that now data management, GDPR, data plan, I don't know, fair data, they are very important. Gender dimension in the projects, they are very important.
Gender, because a lot of people, yes, the gender of the team, but it is the research.
No, gender.
The research
research, the gender dimension covered, yeah. Yes. Blah, 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 blah.
It's very important.
But it's very important. What?
The discussion that we had is to put the blah, blah, blah. It's not about, it's only, not only us. The researchers everywhere are saying blah, 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 blah.
Yes, I know.
We know that we are losing
money
because of that, but we're still considering blah, blah, blah.
Yes.
Just to be mentioned.
But look, if you speak about cancer, breast cancer research, you have to say, because also the men may have. So no, okay. In this case, it's not applicable.
Yeah, it's true. But what another thing I forgot to tell you, but it's important. For example, I learn and I improve my skills to write project proposal, reading evaluation assessment files, you know, when you receive, it doesn't matter if it's from your own project, from a project of your colleague, read this kind of feedbacks because it can improve. Okay, so this is like some steps for you. And I wanted to share also some good experience. I have to, I'm very proud of these projects. They are implemented by us. This is a project, Mount Resilience. It's a big project. It's we have in our project around 48 partners. It's a project with a duration of 5 years. We have 5 replicators 47 partners from 12 European countries. We have 5 demonstrators, and we have 3 replicators. In Romania, for example, we are focused on restoring the meadows in mountain areas. And another thing which we learned from this project, for example, is the fact that we have 2 plots where we need to intervene. And 1 plot is under Natura 2000. And we didn't know this when we wrote the project because it came 1 month before submitting, and we were focused to submit the project proposal, but we didn't check the situation of that part of the field. And now we encountered a lot of problems. In order to intervene there, we need to prepare different documentation. And now we hope in December to get the approval from the environmental agency. But even for us, it was a lesson learned. And this is why I shared this with you, is if you have this kind of intervention where you need some authorization, check before submitting the project proposal. So these are the regions involved. You can find more about the project in mountresilience.eu. Another project, as I mentioned, when we are discussing, it's not just bioeconomy. If we are discussing about chemical things, we also discussing about CBRN, chemical, biological, radiological, nuclear, and explosives. So we have in our cluster a working group dedicated to CBRN disaster medicine, and we are partners of this project, Spark Up, which is under Widera Calls funded. We have another project, Arcoe. This is from also from Widera, financed. Boost, building outstanding opportunities for science and talents. And this is our cluster. I just wanted to share with you, sorry. So we have a national coverage. We have over 128 members in our cluster. And we support our members to enter in different partnerships because sometimes they are addressed to us. And our policy is to go with 1 or 2 partners from our organization when we apply based on their competencies. And as Professor Ficai invited you, I also want you to invite you next week. We have a big international hybrid event in healthcare and bioeconomy. It's bioeconomy, I forgot to write it. It's a big event. It is financed by European Commission through EU for Health project. It will take place at Bucharest Chamber of Commerce near University Square. So if you are available next week, we are waiting you to attend our event. We have international speakers, representatives from European Commission, also the Ministry of Projects. Mr. Pislaru said he will come to speak in our plenary session. And I think you will find a lot of interesting things. So thank you very much. Sorry for how to say. Okay. If there are other questions.
Yes, thank you very much. Just one question, we have time. If,
Yeah.
Only one, and then during the coffee break,
Okay.
I hope that you'll stay.
Yeah.
I just want to add one thing that for cluster 6, the national contact point made a WhatsApp group. And if you want to join, just tell me and I would add you to the group.
So, question? Short
question.
We discussed.
Short question and short comment. The question is regarding the stakeholder involvement. What will be the best for a bioeconomy project to involve living labs or clusters? Because both are for folium, for leaf trifolium and stuff like this. What will be more efficient?
It depends, because, for example, in some calls, they are asking for living labs. If we go to EU mission, for example, they are living labs. Now, depends on the projects. For example, some coordinators comes to us because we have in our cluster the quadruple helix of innovation. We have research organization, we have SMEs, we have hospitals, for example, and this is why they are coming to us, because we can match, but not only match, we can
cover the whole value chain.
When we applied in September, they wanted the Ministry of Health to be partner in a project, because if you manage to bring alongside in your project a ministry, is very important. So because we have this national coverage and we are an actor recognized at national level, we managed to convince the ministry to be partner.
Okay.
We had for another project, we needed another agency, the Agency for Equality and Gender Equality. So we also managed to convince them to be part of the project. So we, as a cluster, what we are trying to do is to assure the knowledge transfer between you as research institution and SMEs. So we are supporting partnership, for example, to transfer the knowledge. But also when we are discussing about international projects, okay, they are coming to us, for example, for IE. Me as a cluster, I can't cover the IE because I don't have the necessary experience. But in my cluster, we have members with a lot of experience in cybersecurity, in IE development, and so on. So when they come to us, we are telling them, okay, we will be partners in this project, but you have to take in the project, to accept in the project, these other tools or sphere organization, because we know they will bring added value. But what I also noticed when we are preparing the project proposal is, for example, we had this issue with the hospitals. We identified the hospital. They said, yes, we are go with you in this project. And when the coordinators started to ask information for the scientific part, they don't respond in real time.
Yeah.
And sometimes, next time I will recommend that hospital or not.
But this is a general history with the seriousness of the partners. And one comment, sorry.
Please.
Depends on the NCP. There are NCP which are not answering. They don't care about. And from my experience, for example, with the Spanish or with the Greeks, they are going to discuss with the NCP at Brussels.
Yes, sometimes like there.
Yeah, so it's a total. So I'm discussing about Spain because it's totally different how their project proposal was evaluated comparing to ours.
I agree with you. I agree with you.
So, and this is about NCP. So it's a double standard, which is not normal in according to the claims and to all the discussion about blah 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 blah.
But you know what I'm saying. I never focus. Believe me, I never focus on what happened. I just take the lesson learned, and from there I focus on what will happen. So if I know this, and now I heard from you, and now I have a new knowledge, I will know to who will address myself. You know, it's very important, this kind of discussion, because we can learn and we can put practice for the next time. Okay, thank you.
Okay, thank you very much. And this concludes our plenary session. We will take a 10 minutes break for a coffee break and more questions. I am sure there are many questions regarding the project development. There will always be many questions. And we'll be back at 30 minutes past 11. Yeah.
Thank you for coming back. We're starting the new section presentations with papers from presentation from Adina Zanlau, Habibi Mawitova, and Abbas Said Asif. They are online. It's about an AI optimized algae cultivation for sustainable biodiesel production. Adina, you are online?
Yes, sure. So, hello everyone. Today we're presenting our topic. My name is IBB and my name is Adina, and we're from Nazarbayev Intellectual School at RAU. And today I'll present our project on the theme of AI optimized algae cultivation for sustainable biodiesel production. Here's our team members. And the next one is introduction. So what's the big idea? Our project explores how AI and the Internet of Things can optimize algae cultivation for efficient biodiesel production. So basically by automatically controlling factors like light intensity, temperature, and CO2 levels, we can help algae grow faster and store more lipids, which are the oil used for biodiesel. That means we can maximize the energy output while minimizing the waste. Next one, there is our research flow, and the first one is artificial cultivation of algae, whereas growing algae under controlled lab conditions. The next is drying, compression, and extraction. The biomass is dried and lipids are extracted. And the third one is transesterification with methanol, where the lipids are chemically converted into biodiesel. Finally, purification of biodiesel. The final product is refined for clean and usable fuel. And so AI can be applied in every stage, especially in cultivation, where it adjusts environmental conditions in real time for optimal growth and lipid accumulation. So the next one is key biological targets and the metrics. To measure how successful our process is, we track several biological metrics, and the first one is biomass concentration. We know how much algae we produce. Then the next one is lipid content, like how much oil the algae is stored. And the third one is productivity, we know how fast they grow per day. The next is contamination indicators to ensure the culture health. And the final stage is energy efficiency, whereas we know energy used per kilogram of lipid. All these metrics help the AI learn which conditions give the best yield and the lowest cost, how we say it, and balancing biological performance and energy efficiency. Here's a control strategy and how AI is applied. So what can I actually there is a predictive control, and we used the ML or mechanistic model to predict biomass and the lipid yield. And the optimization is about adjust by CO2 and the nutrients, which each interval to maximize lipid productivity. And the last one is about benefit, where the balances trade-offs like light and the energy cost. Okay, the next thing that we want to talk about is monitoring frequency. So it's about how frequent do we monitor each aspect, and about pH, temperature, and light. We need to check it on a high frequency, like every 1 to 10 minutes. And the next is OD and fluorescence, which we need to check about like from 10 to 30 minutes or continuously. And laboratory checks like biomass and lipids, and also the imaging every 5 to 3 minutes to spot issues can be in a low frequency. So the next one is about proposed solutions. So we can see two different graphs. So the first graph is without the implementation of AI, and the next is with. How you can see, the first graph is growing very slowly, and with implementation of AI, we can see the instant growth in biomass of algae and in overall growth of algae. And to make the second graph, we need to use vertical cultivation systems to maximize space efficiency, then implement financial incentives, also adapt AI-driven monitoring for scalable automation. So all this stuff helps us to increase the algae growth overall. There is a conclusion, and our findings show that AI and the IoT integration in algae cultivation greatly improves biodiesel production efficiency. Also, it reduces energy use, minimizes human error, and supports algae scale sustainable fuel production. So when we combine green biotechnology with digital innovations, with AI, we take a big step towards making a cleaner and smarter way, and one where algae could play a key role in sustainable biofuel systems. So we want to conclude all our project, and we would be glad to hear your thoughts or questions about how AI can help build the next generation of bioenergy solutions. Thank you all for your attention.
Thank you very much. If there are questions from online.
Which parameter you changed using AI that had most important influence to speed up algae growth?
In our opinion, the most important factors that we used is changing the parameters of the light intensity and also the temperature, yes. And so by AI is like detecting the most comfortable temperatures, and so by that we can really see the growth of algae.
So which one you think had the most important impact, the light or the temperature?
We think it's light, because it gives us overall more growth.
Which one? Sorry, we didn't hear you.
Light.
The light?
Yes.
Okay. Thank you. Thank you.
Thank you. Thank you for your question.
Thank you.
Do you have any other questions, maybe?
If there are no other questions, thank you very much.
Okay,
and we
you.
will proceed to our, thank you very much. And we'll proceed to our next presentation. Ramina Doshan and Abota Yer Sultan will have an presentation regarding the comparative study of banana and orange peel.
Good afternoon. Sorry, 5 seconds, please.
Water
5 seconds.
purification.
Hello, greetings from Kazakhstan. My name is Ramina.
And my name is Sultan Akhbuta.
And today we're going to present a comparative study titled Comparative Study of Banana and Orange Peel Derived Biochar for Efficient, Water Purification. So how you can see, over 2 million people lack safe drinking water worldwide, according to UNICEF findings. So today we're going to focus on converting agricultural food waste, especially banana and orange peel, into biochar, and we're going to describe the methods.
Our goal is to evaluate the efficiency of banana and orange peel derived biochar in water purification, to compare the absorption properties of the two biochar types, and to promote the usage of bio-waste in environmental technologies. To create the biochar, firstly, we washed and sun-dried fruit peels for 12 hours, then cut them into 1 to 2 centimeter pieces and wrapped them in aluminum foil. Then the pieces underwent slow pyrolysis in an oven at 250 degrees Celsius for 2 hours. Then the samples were cooled inside the oven, then crushed and sieved through a 0.5 millimeter mesh. In a large-scale production, however, there's more steps than that, especially treatment. Treatment is important because it enhances and introduces the chemical groups such as carbonyl, hydroxyl, carboxyl, and these functional groups help to capture water pollutants more effectively through ionic exchange, hydrogen bonding, and complexation. There you can see how our biochar filtrated contaminated water, and it works successfully. There you can see methods for official large-scale methods to make orange peel biochar. As you can see, there's more steps and steps for making banana biochar. Okay, so to filtrate water, scientists use water filtration system. It's a big cylinder column, the main body. There's 2 layers of gravel. The first top layer is used to capture large pieces of contaminated water, to pre-filter the water, contaminated water. Then the main filtrated, the most important part is biochar. As you can see, it's the middle part. It serves as the filtrates the water. Then the bottom layer of gravel is used to keep biochar in the place, to not let it slide down. Yeah.
Now we're going to describe how food-based biochar purifies water. So when orange peel or banana peel is converted into biochar, the surface of the material becomes highly porous and also chemically active. So first, the surface of biochar contains many oxygen-containing functional groups such as hydroxyl and carboxyl, and these functional groups can easily interact with dissolved metal ions and also with organic pollutants. So this functional group, when they get into contact with our biochar, with our contaminated water, this functional group form hydrogen bond and also electrostatic attraction and pull them toward the surface. And second one is the fact that carbon structure of the biochar reach in aromatic rings, and this rings helps the biochar to create p-cation interaction with positively charged metal ions. And at the same time, the porous structure of the biochar is like a sponge. So pollutants, they're not staying in one place, they're moving. So when they move into the pore, they're getting trapped there. So it causes a pore filling mechanism.
So how does it work in general? Orange in general has a higher level of carbon and lower level of oxygen. Because of higher carbon level, there's more carbonization of orange during the heating. So it has more pores. However, because of the lower oxygen, it has fewer functional groups such as carboxyl, carbonyl, and because of that, it interacts with water pollutants less actively. Banana, on the other hand, has lower level of carbon and higher level of oxygen. Because of the lower carbon levels, banana it has less pores, so it interacts with water pollutants a little bit less than the orange. However, it has more oxygen levels, and because of that, it has more functional groups such as carboxyl, carbonyl, and because of that, it interacts with metal ions. And overall, orange is more stable, and banana degrades faster. However, it interacts with metal ions better. Okay.
Now we're going to present a comparative analysis. So how you can see on the second graph, biochar shows actually higher environmental impact, but this mainly reflects current production methods. So in many life cycle assessments, it's really important to mention that biochar is made from waste biomass and stores carbon long term. So we can see that this graph does not reflect this point. And also it's really important to mention that in this graph, the scalability of biochar is really high because biochar can be produced locally, also from agricultural waste, and at low cost with great potential and more efficient production. So now data analysis with activated carbon. On the first graph, we can see absorption or removal efficiency over time, and we can see that the graph of orange, banana, and activated carbon have similar trends. So we can see the rapid increase in absorption efficiency of these three methods during the first 30 minutes. It's because there is a large number of available active sites. So after that time, the graph plateaus because all of the active sites are saturated. Now we have the pH graph. pH graph, you can see that the maximum absorption occurs around neutral pH, which is 6 to 7. This is because at this pH, the surface charge is slightly negative, so it can easily interact with, it can form strong electrostatic attraction with positive dimolecules. So if it will be too high pH, then there will be a too strong negative charge, and they will may repel some anionic dye molecules. So it's really bad. And also in the third graph, we can see the material, both orange, banana, and activated carbon can actually handle higher pollutants load, which is great. So overall, we can see that, yes, activated carbon is slightly better. The performance is better. However, the gap is not so high. And we can actually say that, how we can see on this graph, activated carbon, energy demanded to produce activated carbon is significantly higher than the energy needed to produce biochar. So biochar can be produced at low cost and also low energy input, which is really good for our environment. So biochar is a competitive alternative.
So the results of our work demonstrated that biochar derived from agricultural waste, specifically banana and orange peels, can serve as an efficient, low-cost, and eco-friendly material for water purification. Both types of biochar significantly improve the clarity and odor of contaminated water, confirming their strong absorption capabilities.
Yes, and in conclusion, we want to say that the findings of this project emphasize the importance of reusing agricultural waste to create value-added products that address real environmental challenges. And biochar is an underused yet promising material for water purification, particularly in developing regions where agricultural waste is abundant, so there's a lot of them. So by converting everyday food waste into functional biofilters, the study contributes to the global efforts over sustainable waste management and clean water access. Thank you.
So we'll switch to the next presentation. We'll go to the next presentation. Thank you for you. Please close the presentation. Hakem Hassan, Nada Setki, Mohamed Nafie, Noha Mahdi, Item Faudi, Toka Valent Fayed, Edward Price, Udo Bakovsky, and Sherif Abrahmi. Regarding the eco-engineered zinc oxide nanocarrier, a green microwave natural product strategy for sustainable platinum-based cancer therapy. Please, the floor is yours.
Okay. Hello, everyone. First of all, I'd like to introduce myself. I'm Dr. Sherif Fahmi. I'm an associate professor at Philipps University of Marburg. Also, I'm Alexander von Humboldt Fellow at the same university. I'm a group leader for herbal medicine and nanotherapeutic research group, and our research group is concerned about exploring under-discovered natural products with biomedical applications and nanosiding these products in order to improve their physicochemical properties and biological effects. My today's presentation is is an example or demonstration of such work. It's about innovating greenly synthesized zinc oxide nanocarriers, where zinc oxide nanoparticles served as nanocarrier for platinum-based drugs. And in order to achieve this technique, we involve natural product for this biosynthesis in addition to another physical forces. So our target was in treating breast cancer because it's one of the most prevalent types of cancer, and in specific, the triple negative breast cancer. Breast cancer is categorized into several categories. Among them is the triple negative breast cancer, which is one of the most hostile and highly resistant to most of the known chemotherapeutics. So there are several medications that are involved in breast cancer treatment, including the platinum-based drugs, because more than 50% of patients nowadays maybe receive platinum-based drugs if they are gonna take chemotherapeutics. So the major mechanism of platinum-based drugs is targeting the DNA, where they cross-link the DNA of the cancer cell of sure and of normal cells both, causing replication, transcription, and cell death known as apoptosis. Several examples for platinum-based drugs, including the cisplatin, is the prototype and first one used, oxaliplatin, carboplatin, and recently the modified platinum-based drug, the one at the bottom, which is asplatin. And this is the target of our work. So asplatin has some unique properties in comparison to other platinum-based drugs, because actually, as you see from the structure, it's a prodrug. It's composed of both aspirin and cisplatin, where when they enter into the cell, into the body, they just split, where aspirin and cisplatin are released inside the body. And several reports suggested that low dose of aspirin, it has some cytotoxic activity. So when both are released inside the cell, they cause some synergistic activity. But the issue is that asplatin is not found in market. So we had to sensitize it at first before conducting this work, as you will see now. However, though asplatin is promising, but still it has a lot of side effects, such as poor solubility, insufficient penetration to tumors, non-selectivity, and other toxic effects, because as I mentioned, it is released in both cancer cells and normal cells. So its effect is not selective. Thus, we aim to innovate an unorthodox approach to address the limitations of the use of asplatin in specific and platinum-based drugs in general. And nanoparticles nowadays are considered one of these approaches, one of these unorthodox approaches. And there are many nanocarriers, including organic and inorganic, but our work is involving the inorganic nanoparticles. They have the ability to penetrate the cell membrane and carry either the natural or synthetic products into the cancer cells. So to this end, as I mentioned, we biosensitized asplatin-loaded zinc oxide nanoparticles, and we use in this approach gambogic acid, it's a natural product, and microwave assistance, because microwave also help in nanosizing of the particles. So as I mentioned, at first we sensitized asplatin from aspirin and cisplatin, and the yield, as you see, was amazing. It was like 78%. Then we adopted a green synthesis approach because it's environment friendly and it does not involve any high temperatures or hazardous chemicals. So gambogic acid here in this synthesis, when it is exposed to the zinc oxide, to zinc salts, it acts as a bioreductant. It reduces the metal into metal nanoparticles. Also, it acts as capping agent to improve the stability and controlling size and shape. And for sure, microwave was used in order to maintain uniformity and monodispersity of the particles. Now we come to the physicochemical characterizations. We conducted a lot of characterization, but I'm trying to keep it short because of the time. So mainly, we obtained, we conducted XRD, X-ray diffraction, and UV spectrum. And as you see here, the sharp peaks and the spectrum were very characteristic for the zinc oxide nanoparticles, confirming the successful biosynthesis. Also, we measured the surface charge. And as you see here, the zinc oxide and both the zinc oxide nanoparticles and the zinc oxide nanoparticles loaded with asplatin has high negative charge, improving the stability. Also, the encapsulation efficiency of the asplatin over the nanoparticles was like about 80%, which was good. These are the TEM images, transmission electron microscopy. All particles, as you see, are homogeneous, uniform, and we measured the size. It was like between 55 and 85 nanometers. And this was thanks to the microwave assistance who kept the size stable. Then we conducted release study. This study is important because it gave us an indication about the release of the platinum drug inside the body. So we conducted this study in 2 pHs, physiological pH 7.4, and acidic pH because the cancer tumor microenvironment is acidic in nature. So as you see here, the release was markedly higher in the acidic environment as compared to the physiological environment. The acidic environment is the one in black. So this improved that the drug is released in acidic medium, giving some selectivity to the release of the drug. Then we conducted physicochemical in vitro and in vivo anti-cancer activities. First, we started with the MTT assay against triple-negative breast cancer. Always, the violet is our nanoformulation, asplatin-loaded zinc oxide. The pink is the asplatin bare drug without the nanoparticles. So as you see here, the IC50 or the cytotoxicity is much stronger for the nano formulation. Also here, we conducted apoptotic assay or flow cytometry. And as you see here, also the violet, which is our nanoparticles, they possess high late apoptotic and necrotic effects as compared to the free asplatin. Then we conducted in vivo model on rats. we concerned about tumor weight, tumor volume, the first two figures. And as you see here, the nanoparticles caused the tumor weight and volume to decrease in size as compared to either the asplatin or the zinc oxide pair without asplatin. Then we come to the second row. We conducted hematological assay because when we induce cancer in the mice, all the hematological tests are not good. I mean, the white blood cells increase, the red blood cells decrease. So as you see here, the mice normally without any drug, the gray one, you see here the white blood cells, the first one, the white blood cells were high and they decrease when we give the nanoparticles. Also, the RBCs, they were small, little in value, and also the hemoglobin, and they increase because the tumor, the rats start to be healed. So the measurements started to improve. Also, the third row is biochemical investigation. And as you see here, the liver enzymes also were improved. We conducted also histopathological. We took like tissue from the tumor. And as you see here, the lower one on the right, you see here, there are a lot of black spots indicating that the drug or the nanoparticle induced necrosis to the cancer cells. On the other hand, as you see here, these are a biopsy or histopathology for the liver. You see here the right bottom on the right. Here in the tumor cell, there are a lot of black spots in the other figures indicating that the liver tissue is damaged because of tumor, but here the black spots decreased because also of the effect of nanoparticle. So I come to my conclusion to finish on time. So these findings might suggest a promising approach in advancing and progressive strategies for cancer therapy. And also I'd like to acknowledge the funding from the Alexander von Humboldt University and Philipps University of Marburg. And thank you.
Thank you for your presentation. If there are questions, please, Professor Ficai.
Thank you very much for the very nice presentation and very necessary topic, in fact, about the cancer. I saw several papers related to different antitumoral agents plus polyphenols, for instance. Cambogic acid, I think, is in this field. But in my lectures, let's say, I didn't see anything about why to combine with aspirin, with acetyl salicylic acid, which is the reason, because which is the synergy, or how can it improve this antitumoral activity?
Yeah, recent studies have shown that if you take a small doses of aspirin, in addition to the protective effects for sure against coagulation, it has some anti-cancer activity. Aspirin in a small dose. A lot of studies now reporting this, and this is, I think, it's a new approach, like the use of salt in cancer. There are some, trendy approaches. So the asplatin, we didn't innovate the asplatin. It's already there, but it's not sold in market. So the idea behind this is that cisplatin has anti-cancer activity, and asplatin and aspirin in small doses has a little anti-cancer activity. So the idea is that when we attach the two molecules together, they form one big broad drug. When it enters the body, both are released. Cisplatin is already anti-cancer, and the low effect of aspirin, it's synergized by the other. So but although this fact, it's not found. I mean, like cisplatin is found, we can buy it from Sigma, but asplatin, I mean, rare, maybe some companies in China sell it, but not so widely. So this is the idea behind the use of this product. Yeah. Thank you.
Please.
Thank you very much for your presentation. I want to ask you, Cambogic acid was extracted from a natural source, or?
No, we bought it. Our work usually involves the extraction, but in this time we just buy it from a company. It was so expensive.
So it's not really
bio-based.
Because,
we need not to be biased, because the isolated and it might have some impurities or something. So we need the results to be sharp, because we have already sensitized the asplatin, so we don't need a lot of variables. So we just buy it high quality HPLC grade to and also to prevent any impurities, because any impurity will affect the nanoparticles.
Of course,
Yep.
for this I asked.
Yeah,
Thank you.
The effect of aspirin is related to the prostaglandin metabolism, or it not yet known, the mechanism of action?
For anti-cancer, it's not known. Some studies reported it has some apoptotic, some studies also reported because it released some reactive oxygen species, but
yeah, because it's clear that at this level, most probably is not involved with the well-known mechanism of prostaglandin inhibition, because anyhow in cancer cells.
But yeah, maybe yes, maybe also because it's anti-inflammatory, so
it's
cancer inflammation.
It's inflammation. This is another, but most probably it's something related to the activation of the apoptosis.
Maybe
probably.
So I think prostaglandin, it has something to do with
that, and with the mechanism of activation of the apoptosis, P52 and the others, guardian of the cell normality. Please, if there are other questions. If no, thank you once again for your nice presentation. And we'll go future for the next presentation, which will be done by Yerkebulan Zasulani, which will present us the multifunctional eggshell waste bed. If the colleague is online, please, multifunctional eggshell waste.
Good afternoon.
You have the floor. Yeah, please.
So I would like to thank and express my sincere gratitude to the sponsors and PRIOCHEM and ICECHIM committees that allowed the and made the symposium possible. And my project is multifunctional eggshell waste bits for CO2 and SO2 remediation with visible sensing. And I'm from the branch Nazarbayev Intellectual School of Nature Sciences and Mathematics direction, and in Kazakhstan. Motivation and problem. Air pollutants like CO2 and SO2 are major climate and health challenges, and contributing to both climate change and respiratory disease. Most existing sorbents are expensive, and my project aims to solve this problem with the low cost, low energy, and useful bits that can be used in classroom environment as well. Project concept is a eggshell beads of a lavender color with a radius of about 5 millimeters, and they capture CO2 and SO2 gases and change their color to a more pale one after absorbing the needed amount. And they're sensitive to the acidic pH indicator. Research objectives are fabricating eggshells using alginate beads and characterize and quantity and quantify CO2 uptake and SO2 neutralization, and integrate visible sensing via anthocyanin, and assess regeneration and stability to reuse them after one cycle. The materials I used are shown in the table. there are axial powder, mild concentration on sodium hydroxide, and their sources are calcium CO3, and the function of sodium alginate is matrix polymer. Calcium chloride serves as a cross-linker, and anthocyanin from a red cabbage serves as a pH indicator to observe the changing colors of the beads. And bead fabrication. I mixed eggshell and alginate into a 2:1 ratio and added the dye and extruded the slurry dropwise into a 2% calcium chloride bath and formed the beads into a spherical form and rinsed them with water and dried them at around 60 Celsius degree. And characterization of CO2 uptake performance here shown in the graph. It takes up to 30 minutes. It takes up to 0.6 moles of CO2, and after 30 minutes more, it rises up to 0.77 moles of CO2 uptake. And it's suitable for rapid low energy CO2 pretreatment or demo use, and it's also reusable. SO2 neutralization, it simulated SO2 exposure up to 100 picometers and capacity of a half millimole and efficiency of 85% of the theoretical stoichiometry I expected to observe. And products confirmed are calcium SO3 and calcium SO4. Colorimetric sensing, it changed from pale lavender to pink and then whitish pink, like shown on the graph and the picture. And anthocyanin dye from a red cabbage reacts with the acidic pH environment, and CO2 uptake makes it slightly paler, and SO2 neutralization makes it even paler. After each cycle, the capacity recovery is only 60%. So after each cycle, the capacity of CO2 uptake reduces dramatically. But 3 cycles of using
Will you?
I got kicked out of the configuration. Okay. Like, do you see?
Yeah, please.
Advantages is that the beads are very cheap, and it's use waste eggshells that just throw out, and it removes not only CO2 or SO2 but both at the same time, and it provides visible sensing that indicators and sorbents can show. And limitations is that moderate CO2 capacity, and it's partly irreversible, and the capacity lowers with each cycle, and dye is less sensitive to pure CO2, so it's not that detectable. And future perspectives is to make the beads more easy to make and remove the lowering irreversibility and make them more usable in the future. And conclusions, actual alginate beads successfully combine CO2 captures, SO2 neutralization, and visible sensing. It's accessible, it's low energy to fabricate, and to experiment in classroom environments. And I think that it's promising for educational tools and low-cost pretreatment. Acknowledgements and contact references et al, Wang et al, Zhou et al, and some articles related to calcium carbonate and alganates. And acknowledgements, I received no external funding yet, and context is shown here. Thank you for your attention, and questions are welcome.
Thank you for your presentation. Please, question? Online? If there are no questions, thank you very much. And we are moving to our next presentation. Elena Kairatova and Aziz Abbas Zayed, eco-friendly dishwashing liquid from orange and banana peel, a sustainable solution to chemical pollution. Please.
Good morning, everyone. My name is Elena Kairatova, and today I'm going to present my research project titled Eco-Friendly Cleaning Products from Fruit Peels. This project focuses on transforming everyday fruit waste into a biodegradable, affordable, and a safe cleaning solution, promoting both green chemistry and the circular economy. Okay. As you can see in this slide, about 38% of total fruit production ends up as a waste, which mostly consists of peels that are usually discarded. At the same time, most household detergents contain synthetic surfactants and the non-biodegradable chemicals, which contribute to water pollution and the skin irritation. Here, you can see the basic self-forming reaction. Triglycerides react with sodium hydroxide to form glycerol and sodium palmitate, which is the main soap component. So the main goal of my project is to design a biodegradable cleaning product made from local bio-waste and encouraging sustainable practices and reducing chemical pollution. Thus, to achieve this goal, I set several objectives. First, to extract and analyze the bioactive components from fruit peels, then to formulate cleaning products, combining natural extracts, glycerin, and the panthenol. I also evaluated their physicochemical properties, biodegradability, and the cleaning efficiency, and I compared them with the commercial detergents. So these are the materials that I used that include orange peels, banana peels, ethanol, citric acid, and the eco-friendly ingredients. And let's look for the composition of fruit peels. So orange peel are rich in flavonoids, phytoncide, vitamin P, and the glycosides, which provide degreasing and the antibacterial properties. Meanwhile, banana peels contain lutein, potassium, and the antioxidants, which enhance antimicrobial activity and contribute to skin safety. Together, they are both strong base for an effective cleaning product. And let's look for the natural properties and the chemical mechanism of these compounds. So the compound limonene, which is this formula, found in orange peels, and it acts as a natural solvent, helping to dissolve oils and grease. while banana antioxidants, on the other hand, help inhibit bacterial growth. So the reaction you see here shows the formation of reactive oxygen species from flavonoids, which this one, the reaction you can see, which helps break down stains and the organic residues naturally. So actually all of this helps explains and helps to explain the natural cleaning mechanism of citrus-based cleaners without any synthetic additives. So in this slide, we move to the physical chemistry behind foam formation. So the surfactant molecules in this picture arrange themselves at the air-water interface, with the hydrophobic tails facing air and the hydrophilic head facing water. So this alignment lowers the surface tension and traps air bubbles, creating stable foam, which improves cleaning performance. This concept justifies how our cleaner forms foam just like commercial detergents, but in an eco-friendly way. Okay, let's now look at the practical methodology that I actually applied. First, the dried fruit peels were powdered and extracted with the ethanol at 50 degrees for 3 hours. The extracts were then concentrated using a rotatory evaporator and analyzed with a UV spectroscopy. Here, the acid-base hydrolysis reaction explains how critic acid and the vinegar catalyze ester hydrolysis, producing more polar surface active molecules, enhancing cleaning ability and during boiling fermentation. Then, for the formulation, I mixed the natural extracts for the biodegradable surfactant, glycerin, and the panthenol. The pH was adjusted to around 6.5. And to test effectiveness, I performed an antimicrobial test using the agar diffusion method. The product also underwent cleaning tests on glass and the fabric surfaces contaminated with the oil and the dust. And there I used biodegradability analysis, where I incubated in a soil, the sample of in the soil and the river of my city. And let's look at the reaction that underlies in this practical work. Here we see biodegradation of organic compounds, which is actually such as limonene and the citric acids. So microorganisms naturally convert them into carbon oxide, as you can see, and water. So this is a reaction. This confirms that our cleaner is fully biodegradable and environmentally safe, which is good. Additionally, the reaction between organic acids and the glycerin explains the skin-friendly property of the cleaner, and it neutralizes irritation and maintains a mild pH level. So actually, we got this kind of results, which shows the antimicrobial activity of 70 millimeters, a foam stability of 85% that maintains 85% after 5 minutes, then a biodegradability of 92% degradation in 28 days, and the pH of 6.5, which is actually safe for skin. And it is actually cheaper than the commercial products, as you can see in this table. So overall, I want to mention that environmentally, this project reduces both chemical pollution and the food waste. And economically, it encourages local bio-waste utilization, creating a potential for small-scale green enterprises, which is actually supports 12th and the 13th UN Sustainable Development Goals. And at the end, I would like to express my gratitude to my teachers and the mentors at Nazarbayev Intellectual School, as well as laboratory staff who assisted during the experiments. And Also, thank you for Eurochemical Society and the PRIOCHEM for this kind of conference, and thank you for attention. I hope this project inspires more sustainable chemical innovations in our communities. These are the reference, and thank you. I am open to the questions.
Thank you very much for your presentation. If there are questions or comments from the online, if not, thank you very much. We'll go to the next presentation of Didiarkizi Balnur, Amirzan Madina Beykizi, and Beysen Bekova Gulzia, that will present us the Alpha Pure, a biofilter based on food waste and alfalfa for the removal of heavy metals and petroleum products from water body. So we need Didiarkizi.
We're here.
Yeah, please. Please share our screen. Yeah. And please start.
So, hello, dear judges. Could you see my screen?
Yeah, it's perfect right now.
So my name is Balnur, and my partner's name is Medina. We're from Anaya Trau, from Kazakhstan, and we're glad to present you our project called Alpha Pure, a biofilter made from food waste and alfalfa. The aim of the project is to develop and implement a biofilter based on food waste and alfalfa with the effective purification of water bodies from heavy metals and petroleum products. The project also complies with the UN goals like clean water and sanitation, life below water.
The relevance of our project is that heavy metals and petroleum products are widespread industrial pollutants of the environment. They enter water bodies through the discharge of wastewater from various industrial enterprises in Kazakhstan and the Atral region. In Zhaikh River, the problem of pollution by heavy metals and petroleum products is particularly acute, negatively affecting the ecosystem and public health. According to research conducted by specialists with the participation of Ministry of Ecology, the Zhaikh River exceeds class first quality standards for COD, chemical oxygen demands, total iron, petroleum products, magnesium, nitrate anion, and the BOD5.
The knowledge of the research. The Alpha Pure project is an affordable and environmental friendly water purification technology that uses alfalfa and coffee grounds as natural adsorbents. Alfalfa, thanks to its developed fiber structure and high cellulose and lignin content, effectively binds and retains heavy metal ions, and coffee grounds, rich in porous carbon compounds, absorb petroleum products and organic pollutants. So what makes our project unique? Firstly, the filter is completely organic, which reduces the use of chemical reagents and promotes the disposal of food waste. Secondly, the low cost and abundance of alfalfa in Atral region makes the technology accessible even to small settlements. And laboratory tests have confirmed its high efficiency in removing toxic impurities.
Why exactly alfalfa? Alfalfa may look just like a simple plant, but on a molecular level, it's actually a highly effective adsorbent for heavy metals. Its cell walls are rich in cellulose, lignin, and proteins, which contain active chemical groups like carboxyl, hydroxyl, and amino groups. These groups act like tiny magnets. When heavy metal ions such as lead, cadmium, or copper are present in water, they are positively charged. The functional groups in alfalfa have free electrons, so they attract and bind those metal ions through ion exchange and coordination bonding.
Why we choose coffee grounds? Because they are rich in lignin and cellulose, but but most importantly, they contain aromatic benzene rings. The main aroma compounds in coffee grounds first is a caffeic acid, a phenolic acid with hydroxyl and carboxyl groups that bind metals and organics. Then a chlorogenic acid. This is the main antioxidant in coffee, absorbs pollutants. And ferulic acid binds heavy metals and organic contaminants. And lignin is a hydrophobic absorption of aromatic pollutants like oils and phenols. Why is this important for filtration? Aromatic rings attract other aromatic compounds such as benzene, toluene, phenols, oils, and petroleum products. Through a pipe interaction, they stick to each other, and also phenol groups like hydroxyl and carboxyl groups additionally complex metal ions. Role of fruit peel. The role of fruit peel. So orange peel, kiwi peel, and banana peel effectively purify water from heavy metals due to their chemical composition and cell structure, and they act as a natural adsorbents. So what makes them special? All three types of peels are also rich in pectin, cellulose, hemicellulose, and lignin. These substances consist of long molecular chains that contain a functional group such as carboxyl groups, hydroxyl groups, and amino groups. So because of their structure, they help us to absorb heavy metal, and they go like addition to our filter and increase the efficiency of our filter. Research methods. First one is the study of the adsorption properties of alfalfa and food waste, like orange peel, kiwi peel, banana peel, and coffee grounds. Second one is the creation of a biofilter from reagents obtained. And third one is conducting an experiment to evaluate the effectiveness of the biofilter. Our practical part. So firstly, we grew alfalfa, and it took about 2 weeks to grow. Then we try all these reagents, alfalfa, banana peel, orange peel, kiwi peel, and coffee grounds. And then we carbonized all reagents in a vertical furnace chamber at 500, 600 Wait, and then we grind the resulting coal into a powder. The carbonization process. The carbonization process was carried out in a muffle furnace at high temperature under oxygen-free conditions. As a result, the original reagents were converted into carbon material that gained a strong adsorption properties. Due to the transformation of their structure into porous form, they are now able to capture and retain heavy metals and oils. The grinding process. So how you can see, we grind all this like coal into a powder. The creation of biofilter. We measured each reagent at 0.2 grams. We mixed everything together, and we assembled the mechanism using parts that are accessible to everyone. Checking the efficiency of a biofilter. To verify this, we mixed a solution of 1.5 milliliter of lead nitrate with 40 milliliter of tap water, which resulted in a white and cloudy mixture. And next, we passed the mixture through our biofilter, and the mixture began to discolor. Checking the efficiency of biofilter. 3 samples were taken from the mixture, and potassium iodium was added each time to determine the presence of lead ions. As a result of the experiments, the yellow lead iodium precipitate gradually discolored, and by the third experiment, the mixture became colorless. This means that the lead ions were adsorbed by our biofilter. Testing a biofilter for oil product adsorption. So We added 3 milliliters of gasoline and 10 drops of oil to 100 milliliters of distilled water and mixed everything together. And then we passed the mixture to our biofilter.
Next, we conducted a flammability test. In the first video, the mixture of water and gasoline with oil, and in the second, mixture passed through our biofilter. This proves that the filter is also effective for absorbing petroleum products.
So in conclusion, we want to say that the Alpha project is an innovative, low-cost, and eco-friendly solution for water purification because we use natural adsorbents, and it can be useful to industrial areas and also small communities. So in the future, we plan to improve our biofilter design. Thank you for your attention.
Thank you. Do you have some questions?
Thank you very much for your presentation. Question? From online, there are questions? If not, thank you very much for your nice presentation.
Thank you so much.
Thank you. Bye.
We'll go to the another presentation, which will be the ending of our section presentation from this morning. Grigore Șemnovski, Ioan Călinescu, Ciprian Gabriel Chisega Negrilă, Sustainable Hydrogen Production from End-of-Life Vehicle Plastic using Microwave-Assisted Pyrolysis. Please, Grigore.
Every minute, the equivalent of garbage truck is just a couple of seconds to through my emotions. Every minute, the equivalent full of garbage truck, full of plastics, ends up in the landfills and oceans. Every year, over 400 million tons of plastics, which we use only once and just threw it away. The once that was a symbol of modern convenience become the greatest threat of the planet. That's why today I want to present you how we can transform the plastic waste into valuable resources. So ladies and gentlemen, my name is Grigore Pshenovsky, and today I will present sustainable hydrogen production using microwave-assisted pyrolysis. And here in the script or scenario is wrote that must be applause. Applause. I appreciate you. So let's begin. As I said before, every year we produce 400 plastics, but it's ending 350 million tons of as waste, in which 23% of this waste become into mismanaged and light red, or just through the environment in the landfills. Other of that are leaked to the environment in the oceans, lakes, rivers, and also in the oceans as an effect, creating some small islands of the plastic waste. That's why it's becoming a recent or modern threat to the planet. So for this, we are living in Romania, and we also have some problems. Here is an example of the 65 tons a truck being stopped at the border of Romania that is carrying this second-hand, let's say, waste, tires, stairs, and stuff like that, and is becoming also a threat for Romania. That's why we'll start with a definition that is renewable fuels of non-biological origin, which means we obtain fuels, combustibles, that's origin it's other than biomass. And And the political field, we have Directive RED 2, which it's encouraging refineries and big companies to implement the pilot plants, pilot scale installations to use the plastic waste and create the refinery intermediates. And as we continue to the topic that I present, here's a general scheme that we are using plastic waste. We microwave using microwave pyrolysis, and it's common for every pyrolysis process obtaining gas fraction, liquid, and solid residue. And for the next, I present the pyrolysis installation. I will speak very, very fast. That it's simply using a microwave generator and standard waveguide that it's directing the microwave power. Here you can see the parameters we used in our experiments. Mostly the cavity type is monomode or single mode microwave power. To compare, your microwave from home is multi-mode power. The next feedstock that we used is polyethylene and polypropylene granules, or will be labeled as technical. It's a 98% purity. As catalyst, we used activated carbon, being very cheap and very effective. And the receiver, being silicon carbide, it's used as a susceptor or a material that absorbs microwave power. The same from the wastes was used polypropylene from car, yeah, and two types of combined waste, polypropylene and polyethylene from armrest and seat support. The other components are the same, activated carbon and silicon carbide. The next step before making the experiments, we analyzed the wastes. As you can see from thermogravimetric analysis, mostly for polypropylene and the combining, let's say, waste 2 are decomposed totally. But to remember that waste 1 have a residue that don't decompose, which means that in this waste we have some fillers that don't decompose, as also we can see in DTG analysis that has a higher temperature of decompose. So just remember that I will explain later about that. Here's an example of how we filled yes, we filled our reactor with the feedstock. Also, the photo of the reactor filled with the feedstock. It's very important, and that's how you fill your reactor with the components. It's really depending on the results of this. Besides of that, from the pyrolysis application with microwaves, we also use the conventional pyrolysis, which is with the spiral coil and also asbestos. Please don't try it at your laboratory because it's a carcinogenic material. Later from that, we tried different configuration, let's say, or different, we feel different with the material. As you can see, we tried 9 configurations, which the most representative was with number 9. Also, we can see in the results, here will be a lot of tables that we analyzed, but it will be very fast. These configurations was the most effective, giving the highest number of hydrogen. And as a baseline, these configurations that you saw before, we use it later for our for different types of plastics, polyolefins. Here are results or distribution of products for different kinds of plastics, the highest amount of hydrogen was observed in the polypropylene waste from car, but not the last. Also was observed in polypropylene technical, the granules that I presented, but not the last one. And interesting, this one that is we used activated carbon that was recovered from previous experiments, and also it is shown that it still has the activity of the catalyst. Here you can see the GC analysis of the gas fraction. The highest amount, as I said, the most important value was hydrogen in our case, but as a bonus, we obtain a high amount of methane in case of polypropylene granules or technical, as it's wrote here. But also the interesting one, the highest amount of hydrogen was observed in the mixed of polyolefins, which had the fillers, and that was very interesting for us, that were obtained the highest value of the hydrogen, but also in the recovered one with the recovered activated carbon. For the next steps, we apply this formula. I don't wrote it. You can see it here. We can discuss it later at the coffee break. Our goal was the calorific power or gross heating value, but also the CO2 emissions from these experiments. And also, after applying these formulas, we obtain these values, and these values we compare with the commercial fuels. It will be easier to see it here. The highest amount was observed in the sample with the fillers. It has a higher gross heating value or calorific power, even higher than natural gas, which means a higher calorific power, a higher power. That's enough. Even the next sample being higher than natural gas is polypropylene granules, but also not last but not least, and other samples have enough calorific power to burn and to generate the energy, even higher than kerosene. What about the CO2 emissions? In the sample of polypropylene granules, it has lower CO2 emissions than natural gas. But also in the other samples, we can observe that are lower than kerosene and diesel. Also, here we also analyze the liquid fraction. It is most important in our experiments to obtain the lower carbon number. As you can see, from C4, C9 is being gasoline. We can observe the highest amount also was in the mix of polyolefins with the fillers. It was a magical one. I don't know why, but we didn't have enough time to analyze that. But still, the highest amount of gasoline, next with the polypropylene granules and polypropylene waste. It's even 3 times higher amount than the conventional experiments. What about the beta analysis? It's saying that in the microwave assisted pyrolysis, the surface of the activated carbon decreased, which means that have a higher absorbance of the carbonic residue. Also, this I can demonstrate with the SEM analysis, which you can see in the C that it's microwave assisted pyrolysis or activated carbon. I know we are short in time. So we at the conclusion, I'll say from my words, what we demonstrated that microwave assisted pyrolysis, it's more efficient for our experiments. Activated carbon as a catalyst have a great role obtaining high calorific power of the gas, low carbon number and liquid fractions, and also it helps improve the yield and promoting the formation of lighter and more valuable hydrocarbons. In this saying, thank you very much for this presentation, and I think we'll discuss this later.
Thank you very much for your presentation.
So welcome back, everyone. It's roughly 2 p.m. So let's try to be on schedule. As most of you know, last year we started a series of meetings, the Tech Talks Meet Your Mentors. Last year was a meeting regarding the future of research and development, respectively the future of the next generation of researchers, in the absence of a better word. It was about meeting with the mentors of these young researchers and what the science of tomorrow reserves us. As in our country right now, it's a very big discussion about technology transfer, and in my opinion, I was very fortunate that the team chosen, considering the previous days of our conference, where we heard a lot about technology transfer, many words, but very few examples of applied technology transfer and the results that are present on the market. So considering all that, we propose this year a roundtable around technology transfer, challenges and opportunities. I added a subtitle last night when this page was done, the transfer trap, where innovation gets stuck. Because actually the innovation right now in Romania is stuck and we should all admit it. Briefly, Romania's technology transfer infrastructure is weak, low visibility of research results, weak linkages between universities, research institutes and industry. The innovation culture is still underdeveloped. Many firms operate in lower medium technology sectors and do not demand advanced research outputs. Public research institutes' technology transfer performance is strongly tied to their relational capital, networks, collaboration, and structural capital, processes, routines, not merely raw human talent. The stop-start pattern of innovation policy, political inconsistency, and fragmented ministerial coordination hinder sustained investment in R&D and transfer ecosystem. So this was my introduction, and now I will invite, in a very random order, our guest for today. Episystem SRL, it's a Romanian engineering firm specialized in measurement chains, custom control and automation system, as well as 3D design and printing for research, education, and industry. Mr. Petru Epure, please. Hofigal Export-Import was established in 1990, being a leading Romanian manufacturer of natural products, including phytotherapy, supplements, cosmetics, and with dedicated therapy and medical centers. Mr. Tomescu, please. Mr. Porumb. And last but not least, every transfer is performed using advisors. Vimando Business Consulting and Development represents a Romanian management and scientific and technical consulting SME, supporting business development and growth. Mr. Drugulescu, please. So in order to have a very short start and to fit our schedule, I proposed 3 questions. However, please feel free to answer 1, 2, all, or neither. But to have a very sincere feedback from you, where do innovation get stuck in Romania? So please.
Hello. In my opinion, the the innovation is a little bit slow because there are problems with financing, there are problems related to access to competitions, and also there are some problems related to, let's say, financial conformity of the SME, of the private companies. Why? Because there are no laws related to how the Romanian government can support these kind of activities. If a private company starts an innovation project where it's necessary to develop a prototype or a measuring system or, I don't know, a method, sometimes a private company needs help, and this help doesn't exist, or at least is very difficult to reach. That's my opinion. Related to intellectual property, it's easy to apply for a patent, but I don't know why the time to get the patent is very long, and sometimes we need assistance in this endeavor. And I don't know the third question.
Actually, the third was, considering your answers, it's the first. Which structural or institutional barrier most often kills a tech transfer before even starting?
For me, it's difficult now to identify, but maybe I will think about it, and maybe I will.
Yeah, thank you. As I've told you, please address any issues that is relevant to each particular case.
Thank you very much for your invitation. So first of all, I would like to talk about Hofregal research experience. We've been partners in over 50 research projects since 1999. And in the last 5 years, especially in the 2020, we were partners in 4 experimental demonstrative projects and 3 Eureka traditional projects. So what happened? We had foundings for some support on product development and support for some experimental designs for non-conventional extraction methods. The projects were finished in 2022. We had some publications, but for example, from the experimental demonstrative projects, we didn't get that end product. We didn't have the full support to enter the market. So, okay, we have some advantages, no risk experimentation, of course, some infrastructure, but with this kind of budget, we talk about small scale equipment, probably for analysis, and some stuff. Okay, you can include that in your budget. But on the other hand, if we want to advance to talk about real innovation, and for example, last year in the technological transfer programs from the state, we did one project with ICECHIM, our guest, but the funding is around 1.5 million RONs per project. And the coordinator Hofigal has 750. That's around 1,050 euros and 150,000 euros. So when we talk about product development, it's okay. But if we want to scale up a prototype that use non-conventional extraction methods, let's say ultrasound or microwave or combined ultrasound and microwave, to have an industrial equipment, you will need around 1.5 million euros. So is this real technological transfer, or it's just something that the Romanian government is trying to hide between a title? And it's more like an experimental demonstrative type of program. Of course, we are trying to do our best. So we have our own budget and our own investitions in this kind of projects, because we want to be competitive. And we have some support, but in this matter, it's not a real support. And sometimes we have a strong research and development department. And we have partners, even in this room, with great results. But we cannot push it further into the board of the company, because it's a high risk investment. So here, I think if the Romanian government wants to create a big enterprise, not only to support the enterprises to be on a small or medium level, should come with some real investment programs. And there, of course, there are some other struggles because, for example, the last call was in 2024 in January. So they proposed a schedule where they finished the evaluation in July, I think, at the end of July. But in reality, they finished somewhere in November, December. And the contracting phase started in February 2025. So what happened inside our company in this timeline? Some of the key personnel in the project have left the company. Some equipments we have already bought, or some products are already in a stage of development or are developed by other companies. So when they proposed the schedule, the deadline for submission was a fixed term, and you had to apply at that date. But when they comes to their part, the deadline can be moved a little further. So this has some implications in our company, because there is the part of bureaucracy. So you need a lot of justification to change the personnel. You need a lot of justification to buy a different equipment. Even though these actions may enhance the project or the product, but it's not all the time possible, because they say that, for example, if a pharmacist left the company, I need to bring in a project same specialization of pharmacist. So I bring a new pharmacist. It takes around 6 to 8 months to train that person. So 6 to 8 months, it's half of the project, because it's 2 years, but we have some holidays, so it's not effective 2 years. And this is a real struggle, because you have to finish, you have to report, you have to give the expected results, no matter what, with no delay. even they delayed the schedule. And this is a real struggle. I don't know, right now I'm not having any other thoughts on this topic, so I will ask the colleagues. Thank you.
Thank you. First of all, thank you for having me invited here. Why don't we have a lot more innovation? This bothers me from a different point of view. It's baffling that Romanians, as a very intuitive nation, has not possessed the ability to innovate, and I can foresee some barriers here. First, let me think about the first structural or institutional barrier. Well, this is the first headwind for the research. Why? Because we are facing an increasing amount of bureaucracy, and this kills the time in which the researchers may apply their knowledge. For example, we started a project, I don't know, in 2 weeks ago. We applied the first way of receiving funds, and 2 or 3 days ago, and we received since yesterday four delays and letters for clarification. Yeah, and this is baffling because we did everything okay, but well, this is the bureaucracy. Then I believe that we should take a step back and see the larger picture. The larger picture is presented us by the two main actors, United States and China, in terms of funding the research. United States, let's start with China. Why? Because we can never ever replicate their model. Their research is funded by the state. They have so much money, so we cannot go there. So let's look closer to the United States. United States has the biggest and the most fruitful market for research. They are very open to fund directly the spin-offs through their Wall Street vehicles, economical vehicles. So I believe that in the future endeavors that we are going to take, I believe that Romanian stock market representatives should be invited in order to find with them, if possible, a vehicle in which all the innovation, Romanian innovation, may be subjected to Romanian funding. Because I will be eager to spend some money and to invest into startups, Romanian startups, which provide to have valuable ideas and basically to fund the Romanian knowledge and know-how. What happens if ownership? Okay, I can tell you about a project, an European project this time, that we have won at Polytechnica, at university, and it was successful. And then after, I had the chance to open a spin-off in Polytechnica, and I kindly asked our former partners to give me a letter in which they agreed to give me the possibility of using the ideas within the project. Everything went fine up until I asked ABB, the Swiss company, and in return they sent me a letter with 56 questions from their legal department, asking me basically everything. So I renounced because it took me too long to apply for the spin-off. So this is a serious barrier. And the scale up, I don't believe that the scale up of the research is going to be a problem as long as we can provide the funding, because the funding is basically the reason to which all our interesting ideas are going to die, unfortunately. If I may, there is an analogy with an airplane at the airport. So the funding is given to the company. Okay, all the passengers go aboard. They start to work. The engines turn. The plane goes to the departure, and then it went to fund the scaling up of the endeavor. The plane must stop and not take off because there is no more funding. So I believe that identifying means of funding of not state funding but private funding of the ideas could be a winner in our case, due to the fact that the United States has already, I don't know, 60, 70 years of successful privately owned funding. This is my belief. I may have further questions, further ideas, but let me pass the microphone to the next invite.
Thank you. Thank you for the invitation. From my experience as a consultant and advisor accessing funding for companies, first of all, I can say that about the structural and institutional barrier, I think that this level is too rigid, too not flexible for the need of market or industry. Also, I met in time a lot of clients from different industry who don't know almost nothing about innovation in their domain. So I have a conclusion that there is a long distance in Romania between innovation and innovators and the industry and in the economic field. So there are not communication and more than communication, not understanding their roles in the economical ecosystems for a more viable and dynamic collaboration and successful results. For funding, in my opinion, there are some resources, some options, but there are a lot of effort that have to be done from both parts, from inventors and industry, to fulfill all the how to say the needs.
Thank you. If you have something more to add, but before going to questions, I have two small comments. I hope I will remember both of them until I finish the first one. First of all, yes, it's true from us, like as a research institute, it's true that we have some linguistic barriers, first of all, and different type of thinking. That's why the four of you have a scientific background and you are entrepreneurs. This is what is needed actually, because a third party that intermediates between research and industry, it's not a very good idea. But people who have the scientific background as researchers and the entrepreneurship skills and do it for themselves are able also to intermediate such a technology transfer. And the second comment was regarding the funding. Personally, I'm a little bit surprised because I know all four of you had the same issue. All the projects require guarantee letter. So it's required by the state, but no, there is no one that can give it right now. So it's an instrument that is required, and the Romanian government did not implement any state-backed financial instruments to provide such the warranty letter. So if we have some questions from the room.
Thank you very much for your kind presence here. And I want to say to notice a thing. We have only men here. And this is another signal that we have to think about. We don't have women. So why in this kind of high-tech, let's say, business? Because the men are more courageous and they take risks, and the women are more precaut and they prefer to stay. And this is a signal that in fact this kind of business is very at high risk, and it's difficult to be tough in this. So we hope to see also women in the next future. Regarding the fact that a person who intermediates or facilitates the technology transfer, I don't know if it's necessary to not have this kind of person, but I think that kind of person should be a technician, a scientist, not an economist, let's say, or because it's difficult to explain what all the risks, technological risks, if you are only, economist or not really to understand and to explain, to make this translation between researchers, scientists, and the people who want to put the money, but to understand if are at high risk or not, or if they can one. If you remember, yesterday I asked Fabiana, how long is this journey between idea and to market? And also, because they started that startup, I think 6 years ago, and it is a very successful startup in Rome, but they didn't succeed to put on the market any sensor till now, because you have to, at least for health application, you have to pass all the clinical trials and everything. So, and it's difficult when an investor come to us and they ask, okay, and my profit will be, or how much it takes to build the plant and to produce and to sell. It's very difficult to explain to them that, okay, we have to scale up from TRL 6, let's say, to 9, and we need money to to do this. So, but anyway, I see that we have the same problems, us as researchers with funding, and you also with funding. So this valley of death is very difficult to pass, yes, to cross, and maybe we have to together to have some statements for our government regarding the fact that they need to invest. So these are my just comments, not questions.
Thank you. Actually, the fact that we have no lady entrepreneurs invited, I'm sure there are plenty, is my fault, is my bad. But I just realized I was, as a very small parenthesis, I was speaking with Professor Ficai earlier, and he had the same issue at ICECHIM. He just realized, and so this is one more proof that actually I think we in research are gender blind. Yeah, we are. I was just interested when we selected our invitations on their experience on this topic.
Thank you. What I want to discuss, honestly, it's how you are selecting the project where you are entering into the partnership. Because this is also very important. What is the base? Because honestly, I know that it's from our side, even in the project for technological transfer, we are looking for the partners. But how will be the best to select the project what you are entering into the market? What will be the best? We're discussing about this project for the national funds, and let's hope that will be also possible to have on the operational programs proof of concept project where we could also cooperate.
Well, thank you. With respect to the partners that we choose for the moreover the project that we are involved in, first of all, we are screening ourselves to see which capacity do we have in our team, and if there is no capacity, if we have we have to identify one which can be integrated in our team, and then to provide an added value for our project. If not, we just by knowing other companies, we are telling them, look, there is an opportunity, go ahead and take it. So this is the internal screening of our capacities before approaching a project. And then we also make an outside screening of the other partners' capacities in terms of prior involvement in research activities, and if they were or not were successful in their projects. And you were right. And if I add some hero's key in this, I'm just comfortable of being here. Okay, it should be some other women, but I'm comfortable from my family, where the women asks and the men had to respond.
Regarding this, I want to ask you regarding your response. It is your initiative to enter in a project, or you respond to an invitation from a research institute, let's say?
It depends. We had, I'm a teacher, I'm used to speak loud, so I don't need. Thank you. Oh, it's for in online. Okay. It depends. We had some times in which we saw the open the tender. Yes, and we said, okay, can we get into this? We have people that are, or sometimes from European level they called us. So we encountered both situations.
Then do it anyway, if with public financing or not, and you go for this idea, and if it appears tender, you say, okay, we can apply also for also money for one idea.
All my money or the other people money? All the yes, without. If now I'm happy to tell you that now we have put all our money into one idea. I'm not joking. We put one money in one idea, and in 2 years we will prove that it will work.
Good luck.
Thank you.
So from our point of view, we have an extensive background in research projects. So we already have a strong network of partners, and of course through these partners we can also extend the network through their networks. Mainly I think that good project starts from an idea. So from technology readiness level, a very low technology readiness level, 2 or 3. So you get funding for that kind of project. Of course, it takes 2 years. And then if it's validated, you can apply for other funding different kind of call of proposals and to extend that idea. And this is a natural way of bringing an idea into the market. Of course, we have some projects that, for example, we are interested in some technologies, or we identify that we need something inside our own ecosystem to be more self-sufficient. And then we try to do scouting for some partners that can help us to solve this problem. So that's another way of choosing partners and to start a project. And in the end, I think that the strong relationship and this continuous synergic activities between small, medium, and large enterprises with national research institutes will help and will bring more innovation in Romania.
Thank you. If would like any of our guests to answer?
When a competition starts and we start the discussion with our partners, we try to identify if there is a potential development to be implemented directly to the market. So we try to evaluate if there is an immediate application and to see if there can be a product or a process that can be useful in industry or other areas. So that's the first thing that we analyze. Then it's true, we analyze which are our competences and if we can develop more and to learn to develop our expertise. So that's the answer. At the beginning, we evaluate if there is a potential for the market, and then if we can develop our expertise.
Thank you very much. If I may also add an answer, but this is an answer that you know it very well. First of all is the trust between the two parties and the personal connection between the two parties, because no one will risk their money without trust. This is my opinion as the beneficiary of the transfer, you know, because you should transfer from us, first of all. But if there is no personal connection and a good connection between two people and the trust, the idea will go nowhere.
So this, yeah, this I want also to underline and to mention that honestly, we don't need to invent more to generate more technological transfer center to have a network. Is just to have more opportunity to meet, to discuss, to analyze, to realize what is the market potential of our thoughts, well, how to cope with it's not only the bureaucracy. Romanian state, it's a bureaucratic and formal by its nature, since was the Fanariot times. It's also about a space of the European Union which is over-regulated. For that reason was discussed also Fabiana when he presented. For that reason, because of the over-regulations. Okay, it's not good that it's in the United States where it's possible to have medical devices of each types. Yeah, but in the case of the sensors, the market will make the difference. You don't need to regulate. You understand? The sensors are not, okay, it's a wrong diagnosis. You're not going to cancer or to something which is killing. So it's clear that it's an over-regulation which is difficult, and this problem of the over-regulation lead us to another situation. We don't have people, skilled people, cope with all of this, and not for us. This is also on the big economies. They cannot. It's suffocating and it's destroying the business, the research, and everything else. And we just have, ideas of the web of science, most of them which are not valid, honestly. And for that reason, my opinion is that we need this kind of the event where to share thinking and to build trust. Yeah. Thank you.
Yes, this is why also there are several technology transfer festivals. We are part of one consortium that was involving ECOIND, Polytechnica, and the University of Agronomic Sciences. And they are very important, not due to the transfer that is done locally. There will be no such transfer, in my opinion, but on meeting people and understanding their needs.
I think that we have to, because you said that, and this is now the way, of course. First, we have an idea and we have a small project. Then we apply for another project, but we don't know if we will receive the next funding because it is a strong competition. And because of this kind of way of funding, we lose the entire Europe, lose competitiveness regarding China or United States. How to speed this funding and to have just one step or two steps of financing, not 3, 4?
Yes, it's true. And for example, as I said earlier, we had finished 4 experimental demonstrative projects that started in 2020 and finished in 2022. And now on the last year call for proposals, we couldn't bring any or we didn't receive any funding from an idea that started from that project. And there were some good results and some good ideas. And now in this competition, we have won 7 experimental demonstrative projects. And what happened? So the total funding for the project was 50 million, I think, for experimental demonstrative projects. And for the technological transfer was also 50 million. But the amount per project in experimental demonstrative was 700, I think, per cluster. And in the other was 1.5 million. So the rate that they're financing the technological transfer, it's lower. It's somewhere in the half. So probably they should bring more money into this type of projects to get the results that were already obtained into the market. And, it should be a shift in these fundings. So, for example, in this year, I will put more money in technological transfer. So I push the ideas into the market. And in 2 years, I put more money in experimental demonstrative to bring some validation to some ideas and to be an ongoing system like this. Otherwise, there will be a lot of projects that will stop. And we need to have this support, I think, more from the government or from the European institution, because for the other way that my colleague said with private investors, for example, you have a company that it's old, it has 30 years, 35 years, that has its own philosophy that has its own way of doing things, and then you bring in an investor, and he might want to take some decisions that are not according to your philosophy. And do you take this risk?
Well, the risks go both ways. From the funding individuals, from the funding individuals towards the company, and from the company towards the funding individuals. You know, Warren Buffett, 60 years invested in companies, and then for some of the companies he took over the leadership and improved them. Or it's a two-way highway here, and we as Romanians are reluctant to take on the risks, because to go on the market is a risk. To fund a project that is going to go on the market is a risk the same.
Okay, but I don't see it as my own risk. It's some other hand that I have to play by. I'm not sure in your domain, but for example, we have our own ecological crops. So we are now trying to we are in an open procedure to have ecological products. So I bring in an investor, and somewhere on this path, 10 years, 15 years, he will say, okay, let's go for the conventional products because it's more cheaper, we will sell more. And that will not be according to my philosophy, but I already signed the deal with the devil.
It depends on it depends on the percentage to which you allow the investor to take from your company. If it's a 1%, 2% investor, well, it may have a return, but it not gives you indications on the way in which you have to rule your company. And here you're right. You know the best.
Maybe which is your opinion about angel investors? Okay, in Romania it's not so popular as this kind, but let's say in Poland they have a lot of this system with angel investors, and Italy is the same, and they don't intervene on the business philosophy, but okay, it is a high risk, but they prefer to. There is people with a lot of money, so
there are no so-called non-voting stakeholders.
Yes.
Sorry, but please look to the radio. So will be to the news from radio and TV. Will be no longer possible in Romania to have such kind of investors, because usually, in order to cope with European Union over-regulation, this kind of fund are not putting the money in the capital, because they are not, due to the bankruptcy rules in Europe, they are not entitled to take money back. This is one. And in Romania, in Poland, it's working, but in Romania, well, it's not longer working, because, as you know, they are coming as owner, and according to the new law recently voted by the parliament, the loan from the owner transferred to social capital of the company. Yeah, this is very recent. Therefore, it's too high the risk. And for that reason, I doubt that I will see in the future any angel investor coming to loan a company into Romania, because he will become owner, and then ownership will be not longer a loan, but a contribution to the social capital, which will be risky for them. This is the situation.
Thank you for intervention. As we as you've seen also last year, this meeting is only a teaser. So we will end here this meeting right now, but we'll have a 5 minutes, 10 minutes break. We'll start at 3 o'clock the oral presentations for the sections. But in the meantime, I invite all of my colleagues to go on our guests to not let them leave here today without any more questions in the lobby, to profit from them. Yes, of course. So thank you very much for being with us today, and I do hope that at least we raised some more questions, not answer them, but raise some more questions for us to think about it. So welcome back. We will start the plenary session right now with Professor Ridha Djellabi. I do hope that Ridha is online.
Yes, I'm here.
Just a moment. Ridha Djellabi is a chemist with interests and expertise in processes and systems for sustainable environmental remediation and energy generation. He is ranked one of the world's top 2% scientists, issued by Stanford University under Elsevier since 2022. Ridha Djellabi received his PhD from Bagi Mokhtar University in Annaba, Algeria, in analytical chemistry and environment. A part of his thesis was conducted at the University of Milan in Italy, and he carried out a postdoc at LSRE, University of Porto, Portugal. After that, Ridha worked with RCES, the Chinese Academy of Sciences in Beijing, and Shenzhen University in the same country. Then he worked as a researcher at the University of Milan in Italy. Ridha now works as a personal docent investigator at Universidad Rovira y Virgili, Tarragona in Spain, currently being an assistant professor of chemistry at Al Faisal University, Riyadh in Saudi Arabia. He co-authored more than 120 scientific publications, patents, and several book chapters. Today's lecture will be on solar superheated steam for sterilization and H2 generation. Ridha, if you are online.
Thank you very much. Do you hear my voice?
Yes, we can hear you. Right. Thank you very much for agreeing to participate in our conference today.
Yeah, first of all, I would like to thank
your presentation.
Okay, first of all, I would like to thank the organizers, especially Professor Radu Claudio, for the invitation, as well as my friend Anton. So today we'll be talking about solar superheated steam production for sterilization and also green hydrogen production.
Thank you very much, Ridha. It was a very nice presentation. Congratulations for your results, and congratulations for the very applied research that you perform. I would also like to thank Anton for intermediating ourselves to meet, and thank you for accepting the invitation. So if we have any questions from the room, please, or from the online. I don't think I see any hands. Thank you once again, Ridha. I'm sure our colleagues took photo of your email address right now, so I'm sure you'll be contacted by our colleagues. Thank you.
Thanks a lot. Thanks a lot.
We will now pass to the first author training that we will be hosting these days. Emily Young, General Manager at Frontiers in Materials, joined Frontiers in early 2017, first supporting the launch of new titles, as well as the strategic development and the expansion of established titles. She has worked with over 50 different journals, though largely supporting those within the chemical and material science fields. Since February 2020, she has been the General Manager of Frontiers in Materials, a multidisciplinary material science journal that explores the breadth of material science and engineering. Emily has also been General Manager for a number of younger titles, including Frontiers in Sensors, Frontiers in Membrane Science and Technology, Frontiers in Coatings, Dyes and Interface Engineering, and Frontiers in Catalysis. She was based in Lausanne, Switzerland for over 7 years, relocating to the UK in 2024. Emily completed a bachelor's with honors in history with a year abroad at the University of Birmingham, UK. Her international year was spent at Wilfrid Laurier University, Canada. Her studies focused on various aspects of European, Asian, US, and Canadian history. Today, she will present, as I've told you, the first author training on tips and tricks and the importance of open access publishing. Thank you.
So thank you very much, first of all, for the invitation, Professor Firescu, for inviting me to come and talk. I'm very happy to be here on behalf of Frontiers, where Professor Firescu is also an associate editor, to talk to you a little bit about open access, Frontiers in general, and also some publishing tips and tricks for how you can improve your publishing, improve your article preparation, and also make sure that you can hopefully get publication a little bit easier. So the first thing I wanted to talk about is open access in general. There are lots of different types of open access, and the most common ones you might have heard of are green open access and gold open access. They are slightly different in the way that they work, and notably due to how they operate, whether it's behind a subscription or hybrid journal, or in our case, fully open access. Also, when that access becomes available, whether there's an embargo period or it becomes immediately available, and typically whether there is an archiving or publishing fee. So Frontiers in general, we currently publish over 220 different titles since the company was established in 2007. Frontiers in Materials, the journal that I'm here representing, was launched in 2014, so it's just over 10 years old, so we're still quite young in the grand scheme of things. But as you can see, we have rapidly expanded in the last few years. And now we have also 14 partner journals as well with various societies. How our journals work? Typically, they are a broad field journal. So in the case of mine, it's Frontiers in Materials. And these cover broad areas of research, bringing together different communities within the field of materials science. We have 15 different specialty sections within the journal. There's a few listed here. And each of these have a dedicated chief editor, associate editors, and reviewers as well, to make sure that any papers that are submitted have the relevant experts to peer review them, but also there to discuss the findings. One way in which we showcase our content, of course, is through published articles, but we also have article collections called research topics, very similar to special issues, and these bring together different ideas around a common theme. These research topics are slightly different to special issues, while they are very similar. They are open and collaborative, similar to the sense of open access. They allow for multidisciplinary and interdisciplinary discussions, as we're able to list them within multiple different journals. So it might be at the border between material science, biology, and various different areas as well. They are different in that they are defined and led by the researchers themselves. We provide the support, but we don't tell them what they have to focus on, as long as it is within the scope of the journal. And the aim is for them to stimulate discussion, accelerate discovery, and also being open access. They are highly cited and widely read. Here is an example by Professor Firescu himself and many co-editors. And as you can see, we had a number of papers, and it was viewed globally all across the world. This is a big benefit of open access, not unique to Frontiers. Every open access publisher will have this benefit, in the sense that because it is freely open and freely accessible, your research can be viewed and downloaded and also cited globally. So this is the data as of June for Frontiers as a whole. We have 4 billion article views and downloads and 12 million article citations globally. And you can see, of course, there are certain hotspots within where you see typical research centers, but we're also touching very remote locations as well to show that wherever you have an internet connection, you can access research. In the sense of open access, we know that there are also challenges to this publishing model. And we know that this often is down to the APCs that come with this model, the publishing fees. We know that for some researchers, this can be very difficult to support. Maybe your funds are very limited. Your grant may not have sufficient funds for open access publishing. Maybe your institution doesn't have agreements with different publishers. We're very happy that the institution we're in today has a partnership with us, but we know that that is not the case for every researcher. So what are we doing about that? How can Frontiers support you as a researcher? Currently, we have nearly 700 partnerships worldwide with different institutions. These are largely centered within Europe right now, but we are expanding into Asia, North America, and also into Oceania as well. These institutional partnerships help us to support global access and sustainable access to science, making sure that more researchers and society in general can access the research. These partnerships are also flexible, allowing us to remove the cost burden for many researchers as well. We've also been taking this a step further by building on these institutional partnerships to have flat fee agreements. So this may be something you're already aware of or perhaps not. Typically, a flat fee agreement allows us to have one universal, typically annual fee that's paid by the institution or by the library, meaning that researchers never see a publishing fee. In their eyes, it's free to publish, and as long as they're affiliated with the center in the correct manner. This, of course, improves author experience. It improves transparency for the institutions, and they can leverage their funds in a much more useful way for them and really reinforce the research behind the research that is published. Currently, we have just under 80 of these agreements with different institutions, and we're expanding this every year to make sure that we can make science much more equitably open and accessible. We've also been recently discussing with consortia and national groups of universities. We were one of the pioneers to really bring these types of agreements together, and I've listed a few on the slide here: Germany, Luxembourg, Norway, Qatar, Slovenia, Sweden, and Switzerland. And these really allow us to support researchers in those regions, and we're looking to expand this in the coming years as well. Another way that Frontiers is really supporting researchers through open access is by making sure that research is globally open and visible. And of course, there are certain metrics that we know, the journal impact factor, site score being one of them. But we also know that there are other ways to evaluate a researcher and evaluate their success within the community. The Declaration on Research Assessment was launched in 2012 in San Francisco, and this is something that we are a signatory of, and we believe it's very important to make sure that we don't just measure a researcher's success by the journal impact factor or the site score of where they publish, but also looking at their work as a whole and making sure that they're also being seen and valued for their research. Another way that's quite unique that Frontiers operates within the community is quite novel, so you might not have seen it. We also have a journal for children, for kids. This is quite fun, it's quite unique. I encourage you to go to their website, where what they do is they take existing published research and they rework it for children. So if you're a researcher and you've published a paper, you would rewrite it for various different age ranges, could be as young as 7, could be as old as mid-teens, and then they will peer review your paper. And as you can imagine, kids tend to be a lot more brutal and a lot more direct with their feedback. So it really is a good way to practice your communication and really how you can make your work much clearer. We're also working to translate this into different languages as well, and also to bring on board even more groups of children and affiliations as well. One way that we've been doing this to really capture the best sort of research globally is our Nobel Prize collection. So we've been working with various different winners of Nobel Prizes. We're currently on the 4th volume, which currently has 3 papers published. Ben Feringa, you may be familiar with within the chemistry space, as well as Jennifer Doudna. And these are really allowing us to showcase the best of the best and bring that excitement to children as well. One thing to keep in mind when it comes to open access is quality. This is not unique to open access, but it is sometimes a potential prejudice that is levied against open access publishing, maybe concerns about peer review and research integrity. And so I wanted to talk a little bit about that today. Our peer review process at Frontiers is quite unique. It is collaborative, it's open, while still being single blind, and we have various different stages where the manuscript goes through. Throughout that, there is research integrity in every different stage, and it's really important that we emphasize this point, because only validated quality research can really gain the trust of society, can build trust within your research community and help us to accelerate advancements. And this is a commitment that we're very strongly behind in Frontiers. We have not only done this at a broad scale, we've also launched a dedicated team. They go through every single paper before it goes out to peer review. And this means that we do reject a high number of papers before they even get to our editors. both saving valuable time, but also providing that feedback to the authors on how they can improve where appropriate, and also making sure that they're redirected to a more suitable home if the paper is not fitting for us. We do use AI to support these checks. Of course, when you're receiving many papers every day, it's important to be efficient. So we have been pioneering different tools to do this. We use a tool called IRA, the Artificial Intelligence Review Assistant. This was created in-house by Frontiers, and it performs over 50 checks every single day on every single manuscript to aid our teams and our editors who now have visibility on these checks as well. It is worth noting that AI is not infallible, and this is why it doesn't take the final decision on any paper. That's always made by a human, whether a member of our team or the editor themselves. And this is something that we are part of an industry level collaboration. We need to work together as different publishers and with researchers as well to make sure that we maintain the level of integrity and ethics globally, as only in this way can we really ensure the quality of publications. So we also do regular webinars. There's one on the screen here and another one here more specifically about artificial intelligence. So this is something that we do sort of virtually as well, similar author trainings. Now that we've talked a little bit about open access, I also wanted to spend some time on tips and tricks, how you can get published and how you can improve your writing as a researcher. So I really want to take us back to the very beginning, making sure that you can really improve your chances before you even submit your paper, whether to Frontiers or any journal. It's important to select the right article type for your manuscript. It might sound really simple, but we often see papers that are not fitting the description of the article type, not having the right segments to the paper. So this is really something that you should check before you submit, as even if they have the same name at a different publisher, there's no guarantee that those article types are the same. So do make sure you check before submitting, as that may avoid a direct rejection. Similarly, make sure you review your manuscript and ask your colleagues or your supervisor if you need. You've been looking at that paper for a very long time. There might be things that you miss, simple errors that could be avoided. And similarly, make sure you comply with any submission criteria or editorial policies. It's usually very publicly visible on the various journals' web pages. But if you're ever in doubt, reach out to the journal. They'll be more than happy to assist you with those queries. And finally, a little bit of advice on this point. Sometimes different journals allow you to submit your recommendations of reviewers or editors. This is something that we do. Make sure when you are submitting any recommendations that they are geographically representative. This not only helps you, but it helps the scientific community. And of course, avoid recommending colleagues with an obvious conflict of interest, your supervisor, a recent collaborator. We're not going to be able to invite them to peer review. And so it's going to waste your time, it's going to waste their time, and potentially slow down the review of your paper as well. When it comes to choosing a journal, there are different things to consider. Maybe you think, I'm just going to go for the best impact factor. I'm going to go for the journal that I've always published in. Maybe those are good choices, but it also is something to consider that maybe you need to look outside of your usual realm. I would encourage you to consider 5 key areas. First of all, the ethics and integrity of that publisher or that journal. Is it a member of various bodies? Does it have the metrics that you would imagine? Or is it looking a little bit shady? How is the reputation of the publisher? Is it a well-known journal? Does it have those good ethics that you would expect? Then it comes down more to the specifics of your paper. Does the scope align with the paper? Does it match what you're looking for? Similarly, is the audience correct? Are you looking to reach a broad audience or something more specific? Is it known in the field? Are people going to be able to find your work? That may not always be obvious. And similarly, indexation. Sometimes institutions or funders may mandate that you have to have a certain impact factor, certain level of quartile, for example. Make sure that you've checked all of these requirements before submitting to avoid losing time in peer review. I didn't want to just give you my perspective. I also wanted to give you a few of our chief editors' perspective. I have a few on the screen here. Professor Dye is based in University of New South Wales in Australia. He's the chief editor of our energy materials section, and he really wanted to emphasize that you should choose the journal based on the scope, not the impact factor, so really reinforcing that element there, but also that you should work yourself on improving your writing skills, not relying on an advisor, similarly not relying on AI to write your paper for you. When it comes to AI, this is obviously something that is becoming much more in our day-to-day, something that we're using on a regular basis in many cases. Every publisher and every journal will likely have their own policy, their own guidelines on how you can use this. So I wanted to give you a bit of insight into how we have a policy at Frontiers. And I've broken this down into text, figures, and images, authorship, and then more specifically by our editors and reviewers. The main thing to be aware of is make sure you declare any usage. It might seem simple, it might seem something basic, but make sure you declare it, because if we find out at a later date, again, that could slow your peer review down, it could cause issues, it could raise ethical concerns. When it comes to authorship, don't list AI or any Gen AI tool as an author. It sounds very simple, but we do see it, and this will raise flags internally, and it may put editors off when they see your paper coming onto their desk. Ultimately, the author themselves or group of authors remains responsible for validating that factual accuracy. Don't rely on AI to do it for you. It won't always find plagiarism or potentially mistakes. And we also have very strict requirements within the peer review as well, making sure that our editors and reviewers are aware. So we stipulate that the content of a manuscript must not be uploaded to external tools. This is primarily to protect confidentiality and intellectual property. How would you feel if somebody uploaded your paper to an AI tool and then you lost that insight? But also making sure that you are responsible for checking the accuracy as well. When it comes to peer review, there are some things you can be aware of to sort of mitigate any errors or any issues. As we've discussed, make sure you're submitting to a journal that fits the scope. It's quite simple, but it does happen. Make sure as well that when you submit, you have a good level of English and there's no formatting errors, and make sure that you also provide adequate responses and adequate revisions if you are requested to do so. As we see, common reasons for rejection could be lack of novelty or significance, if that's something that a journal does reject for, could be ethical issues in the paper, non-compliance, or just a weakness in the paper in general. So these are things to be aware of and keep an eye on. I asked the chief editors again, what do you look for in a paper, as they're the ones that have to validate an acceptance for us at Frontiers. They emphasize making sure that you have clarity, everything is clear, make sure that a researcher who maybe is familiar with your field but doesn't know it intimately, can they understand what you're writing? Is it translatable? They focus a lot on data, making sure that your data is appropriate, it's analyzed well, but not overinterpreted, and also making sure that you are concise and make sure you have sufficient detail for reproducibility. And this is becoming even more of a hot topic of conversation in this day and age. At Frontiers, I also wanted to emphasize that there's a lot of support available for authors. I know this is the case for various different publishers as well, but you're not going it alone as an author. We're here to help you as well. So this could be on your specific paper, providing support through guidelines, personal one-to-one support, whether myself or my team. We run our regular webinars, and we also have dedicated teams to support you in different aspects if you ever have a question and you can't find the information on our website. We also engage with the community. I'm here today talking to you, but we also do online webinars, and we're very much interested in doing author trainings with your institution, with your group, if you want something much more specific or more tailored. We also support networking with researchers around the world. We try to bring together our editors and authors in different areas to really build those connections. And we also give researchers at all different levels opportunities to broaden their horizons, gain experience in peer review, lead collections, or be involved in different ways. And lastly, I wanted to emphasize how open access can really be a benefit for you in increasing the visibility and impact of your research as well. The open access model allows you much broader accessibility, enhances the visibility of your research, and therefore potential impact as well. This wide dissemination is not only via our website. We actively promote various articles on our social media, via newsletters, and also via press releases led by our communications team to really make sure that your research gets the recognition that it deserves. As a journal, we of course have various different metrics. We have journal impact factor, site score, and various indexations. but we also have article level metrics as well. And this allows you as an author to see how has your paper been viewed, downloaded, and cited globally in real time, and so you can see how it updates every week. Research topics I touched on already. This is very similar to a special issue and allows you to curate research around your specific area of interest. This collaborative nature allows you to build new networks, new collaborations, and maybe find others working in your area of research. And similarly, I wanted to highlight that we do offer a lot of support for how to communicate your research as well. We can provide you with visuals if you're going to a conference or you're going to give a talk. Maybe you want to have a flyer, we can help you prepare that. And we also are able to support you in promoting your research much more widely as well. So that's everything that I had. I may have gone through things very quickly, but I wanted to make sure that we had enough time in case there's any questions. And also, as I know it's the afternoon, to make sure that we cover everything in good time. Thank you very much.
Thank you very much, Emily. We at ICECHIM are the big supporters of open access publishing, and it's a fact that we assumed publicly. It's not something very secret. So if we have any questions from the room, of course.
Okay. So it's not that I am, in charge for the question. Now, as I mentioned, also my colleagues, we are pioneering and support of the open access. And maybe, probably you know, from the academic community from different parts of the Europe, including from Romania, it's a movement of rejection of the open access. It started with your, starting from the Chinese, located also in Switzerland, because theoretically they are also Switzerland company, MDPI, and starting from them and also on Frontier. One of the things that they are saying, these advocates, which are against the open access, is the fact that you are relied too much in research topics, special issue. Yeah? And the guest editor from these research topics are not validated by different methods. And here I would like to have a comment. How you are selecting the research topics and the guest editors in order to assure the quality of the editorial process? Yeah.
So thank you very much for your question. This is an excellent comment, and it is something that is very much at the discussion of many open access publishers. You mentioned MDPI as well. So this is something that we've really taken a look at recently. We know that there are concerns. We know that the research community wants to understand more and wants more transparency. So at Frontiers, what we've been doing in the last couple of years is really consolidating the topics that we choose. We're having less of these special issues, research topics. Of course, every publisher calls them something different, but they're very similar. So we're having less, really focusing on what are the areas that the community wants to see, what are the areas that are going to be the most influential and the most impactful, and also making sure that our editor-in-chief is aligned with that, making sure that we have their stamp of approval before launching. So that's fundamental in terms of picking the topics. When it comes to the editors themselves, we have in-house criteria that we now set as a standard benchmark. If they don't meet that criteria, we won't be able to move forward. This is not to block anyone from being involved, but we have to make sure that that quality standard is understood. When it comes to the quality of papers within those collections, obviously, we want to make sure that that is trustworthy, and that everybody understands what they're looking at. So within Frontiers, we've implemented an additional number of checks. So whenever a paper is submitted, it goes through a range of different checks. If it's submitted to a collection, a research topic in our case, there are additional checks that it goes through. We look even now at things like potential paper mill activity to make sure that these collections are not being manipulated. And any paper that goes through in a collection has to be validated by the chief editor before it goes to publication. So what that means is sometimes we might see something that goes through very smoothly. The chief editor raises a concern, back it goes into peer review. And we have to have their validation before it passes through to acceptance. So this has slowed things down a little bit, but I personally believe that it is for the best. It's best for the journal, it's best for the community, and it really helps us rebuild that trust around these collections as well.
Because I have not only from my personal experience, also from my colleague, but also from my personal experience, even in Frontiers, the guest editors were very slow in decision. This was previously, so it's good that you have more times because this will speed the process. In the case of non-serious person with just one for their career to prove themselves as being editor, and they don't understand the responsibility of being editor. It's not something that you should pride. It's something that you should take on your own responsibility. If you are a leader, you have responsibility and not rights. And it's difficult for the people to understand that. Yeah, thank you very much.
No, you're very welcome. And it is important to remember that as a guest editor, you're still the editor of the collection and you are responsible for the content that's there. And it's why in many cases we have been working much more closely with our editorial board members. And they know our policies, they know our guidelines. And we have much, much stricter requirements now for external editors. And we make sure they go through sufficient training before they handle any papers in peer review as well.
Thank you. If we have any other questions, if not, I have a short comment. It's more of an in-house discussion, but the quality of a paper cannot be judged by the journal it's published in. We've seen several various quality papers in very different publishers. So a definite conclusion cannot be drawn by the journal it is or the publisher that publishes the work, but individual work should be evaluated individually. Thank you very much for being with us today.
Thank you.
Thank you.
Good afternoon, everyone. It is a real pleasure and a personal honor to introduce our invited speaker, our last speaker, but not least, for this session, Professor Ahmad Ali Omari from Jordan University of Science and Technology, Jordan. Professor Ahmad Omari is a full professor at the Department of Physics, Jordan University of Science and Technology, where he has served in multiple academic and leadership positions, including head of the Department of Applied Physics and Dean of the Har Al-Batin of Technology College in Saudi Arabia. With a PhD in Chemical and Materials Engineering and Physics of Thin Films and Nanotechnology from the University of Nebraska-Lincoln. His research interests focus on thin films fabrication and characterization, nanotechnology, optical coatings, biomedical alloy coatings, polymers, and energy-related applications. He authored over 150 scientific papers in international journals and has supervised or co-supervised more than 45 master students. Professor Omari has been recognized as one of the world's top 2% scientists this year and also last year, according to the Stanford Elsevier Global Ranking, and was honored by the Jordan Physicist Association as a distinguished physicist in Jordan. His expertise spans across advanced thin films, deposition techniques, nanocomposites, catalysts, and water treatment, with applications ranging from renewable energy to biomedicine. Beyond his impressive scientific achievement, I had the great privilege of meeting him earlier this year at the JUST conference in Jordan, where we began our collaboration. I can tell you firsthand that he brings not only scientific brilliance, but he's also a spirit of generosity, creativity, and good humor to every idea. Professor is the kind of scientist who lifts everyone around him, and it's a pleasure to call him both a colleague and a friend. Today, Professor Omari will be speaking on electrochemical performance of air-doped titanium film for energy storage application, a topic that promises to be both timely and thought-provoking. Please join me in giving him a very warm welcome. Professor Ahmad, it's a pleasure to have you with us for the first time at our conference. The floor is yours. Thank you.
Okay.
Okay, great.
Thank you. Again, let me start. The title of my talk, Electrochemical Performance of Iridium-doped titania film for energy storage applications. I am again Ahmad Omari, my colleagues in my University of Science and Technology in Irbid, Jordan. I would like to please, I was supposed to be there with you in person, but there was some circumstances which made me go back to Jordan. This is Jordan and that is Romania. Went long distance to reach there. Jordan, let me see, I live here in Irbid, which is at the north part of Jordan, where we have many tourist places. Anna and some other colleagues have visited on places at the north part, Jarash, and some other 5 cities, Romanian cities in Jordan, Jordan River and baptism, as I'm saying, places of tourists. You may be interested to come. Petra is the 7th wonderful wonder in the world, and Wadi Rum. Anyway, this is my university in Jordan. It is very close. If you look there, you can see the borders of Syria. This is the main gate, and our main hospital, maybe the second one in Jordan. Let me go down, start my talk. I would like, I don't want to be that long, so I will start soon. I'm sorry to repeat my apology again. Abstract and introduction. Ali. Abstract introduction, objectives of the study, materials and methods, results and discussion and conclusion. Okay. Effective energy storage technology is crucial for sustainable, renewable sources or energy sources, and electrochemical supercapacitors. We are working now on supercapacitors, which they have applications in electric vehicles and renewable energy. They have high power density, excellent cycle life, and rapid charge discharge characteristics. Titania also again, they generate and store energy through the electrical interaction or interactions between the electrodes and the ions and the electrolyte solutions. This work investigates iridium-doped titania films and electrode material for supercapacitors in comparison with undoped titania. So we have iridium-doped titania and we have a pure titania. Iridium doped improves capacitance, rate capability, energy density, and cyclic stability in both base and acidic electrolyte solution, KOH and H2SO4. So we'll test them on both. Supercapacitors, mainly there are 3 types. One is electrical double layer capacitors, and pseudo capacitor. There are capacitive Faradaic mechanism of interaction, non-capacitive Faradaic and EDL that will make the third type of capacitor is a hybrid capacitor. In order to let every type of the capacitor, EDLC capacitor, the mechanism of how do they interact, charges are stored at the electrolyte electrode interface, through a series of reversible Faraday redox processes. Typically, they use carbon or carbon oxide-based material, while pseudo-capacitors, the charges are stored at the electrolyte-electrode interface by redox electrochemical process. Usually, they use polymers and metal oxides. However, the hybrid capacitors, they use the two mechanisms of interactions. That is the one we will use right now in this study. Why did we use titania, TiO2? Titania exhibits unique physical properties, including high transparency, wide band gap, high refractive index, and the ability to be easily doped with active ions. There are three kinds or types, phases of the titania. We will concentrate in anatize rather than the rutile and brochite. Well, anatize phase titania dioxide is well suited for solar cells and optoelectronic applications due to its enhanced catalytic activity. That's what we are going to use in our study. It's excellent electrode, titania, due to its superior electrochemical its electrochemical properties. I'm sorry, this here. And stable structure and long life cycle. Why did we use titania again? Because doping titania with deep-coated iridium ions decreases the band gap energy, reduces the whole recombination, and increases the electric conductivity, which is supposed to be like this, and that we have to see if it goes or not like this. Okay, let me. Are we okay? Do you hear me? Okay. There are many methods where you can make titania and iridium doped titania, but we use Sol-Gel because it is it gives homogeneous. It gives homogeneous. Okay. It gives homogeneous thin films. The Sol-Gel was employed due to its excellent film homogeneity, ease of compositional control, and capability for large area coating, and cost effective. Okay, as I said in the beginning, we have used anatize, where we have here titanium and we have oxygen, and iridium will be in between. Iridium has a very high atomic number compared to titanium. Whenever iridium replaces titanium, then we'll find changes in the microstructure. We will look for that in a while. So we are trying to investigate the difference between pure titania and iridium doped titania. We will see that. What to do. For this purpose, the electrochemical charge storage based on an ITO substrate coated with undoped titania and iridium doped titania films was investigated using voltammetry, cyclic voltammetry, and different scan rates in both basic solutions and acidic electrolyte solutions. So we use titania alone, titania with iridium, both of them will be in say both of them will be applied to basic and acidic electrolyte solution. The physical properties will be compared in order to see what are the differences between the undoped and the doped material. Usually people are not very much interested in the details of experimental, but I have a shortage of time, and these are the the way how do we start the material, how we develop the material. I don't know, shall I go through them, or they will be available if anybody wanted to ask for them. Combination of titanium isopropoxide, TTIP, prepared mixing and steering with 19.1 million isopropanol for 1 hour at room temperature. Also, rhodium was added, there, and then diethanolamine solution was prepared by mixing and steering different quantities. Finally, the resultant films were annealed at 550 Celsius for 1 hour. The TTB solution was added slowly to a DEA solution under continuous steering for 4 hours at room temperature. The resultant solution was filtered by 0.45 micrometer filters. The iridium-doped titanium solution was deposited by immersing them, in fact, deep coating ITO substrate in the prepared solution for 2 hours. The films were dried in air for 70 degrees in 72 hours. Now, this is the most important thing in the talk. Characterizations will use X-ray and scanning electron microscope, EFM, X-ray, fluorescence, UV vis, and 4-point probe for conductivity. Let me go here to see the X-ray diffraction for the material. This is undoped titania, and iridium-doped titania. If we look at them, we'll find some changes somewhere over here, somewhere in this peak. In order to see what makes difference between them, we take every scan and make fitting by right field profile fitting for both of them, and from that software we can find out what are the parameters of the crystallinity of both materials. Let's go there and see what is in. This is the titanium and the iridium titanium, where I said before coming in between. That means the electron density distribution will be affected. This will be that was simulated, in fact, in order to see this distribution of the two, the effect of the iridium in titania, in addition to when iridium enters the microstructure of the titania, it makes some changes like stress strain, like changing the lax parameters and so on. We'll go and see this table summarizes all those fittings by the software, and we can find out lax changes. A equals B, those are almost very little changes, but it is. And C, no changes almost. The change was in the base of the structure. The profile factor, we see as we look over here, we find whenever we have iridium, there is an enlargement of the profile factor 19.632, while drag factor 2.9, 13.7, weighted profile factor 2027, and expected. Those parameters, they come out from the software we have used. Errors, also the similarity, the crystallinity, also it has been enlarged. Let me see if I can find it. Yeah. Sorry. Go back to that. So see, the crystalline size was with titanium alone, with titania, sorry, alone, 18, while with the iridium it was 46, which means there are a lot of changes in the microstructure. We have used now the SIM, where we have this without iridium. There would be a kind of strong roughness comes up to the surface. If we look at X-ray fluorescence for both undoped and doped, we can see the three phases of iridium. How did it enter? It was not there in undoped titania, while with iridium doped titania, now we have the three phases of, incorporation of iridium in the titania. The AFM also shows the surface morphology for the titania and iridium doped titania. In fact, as we see, the undoped has in roughness, that was 5 nanometers, while in iridium doped, because of the high atomic number of iridium, it is 20 nanometers. The surface roughness. Now we go back to the optical characterization. We have used the UV spectroscopy. As you see, the iridium is almost transparent in all the visible spectrum. However, introducing iridium reduces the transparency, and over here we can guess also that the band gap has gone. This is where the absorption has started, and that is because of iridium when it is enters inside the structure of the titania. The absorption also gives similar structure. See, we can see the absorption started from here. That is an indication where the band gap of the material will start. And we use tau plot. Tau plot, that is the absorption coefficient multiplied by the energy squared with the energy itself. That gives linear extrapolation of the absorbance in this form. That is with iridium, it is 2.87, while it was 3.1 without iridium. Again, as we said in the beginning, it should increase the conductivity. This is using 4-point probe on the surface of the film, where you can see the color. The red color shows how the conductivity is high and the blue is low. So this is made by 1 centimeter by 1 centimeter from the surface of the sample. And we take usually the average of the conductivity. The average of conductivity was 4.99, which is 5 to the minus 5, while here it's 1.20 to the minus 4, which has increased, the conductivity has increased a lot. Similarly, this is a view also, the band gap has been representative in the energy band level, this way 3.1 to 2.89. Oh, sorry, 2.7. And now all this, what we want it to be as an application for superconductors. The electrochemical energy storage performance has to be used in cyclic photometry for different scanning rates of titania film in basic electrolyte, while iridium doped titania with also basic titanium. This is titania, this is iridium doped titania, that you can see over here at different scanning rates. This is undoped, this is doped. If you look at the area that you can guess which one is better or giving more at 400 millivolts per second, that would give me in basic electrolytic. And this is the specific capacitance. That's what we want as a function of scanning rate. As you see, the blue color shows that the iridium has increased at any chlorate we have used in the experiment. However, in the acidic electrolyte solution, again, similarly, this is for undoped and this is for doped, and also in this, the resultant will give you specific capacitance as a function of scanning rate, and it's obvious that erbium make changes to the capacitance, to specific capacitance. Now, there are some other things I didn't want to make it longer because already I took a bad time. In fact, in the beginning of the talk, I'm sorry about that. But in conclusion, we can see that the significance of erbium dope on physical properties of anatase titanium film for energy storage application was demonstrated. The erbium dope acted as a promoter for grain growth despite the increased lattice strain introduced by the incorporation of larger erbium ions into the titanium sites. This led to a substantial increase in crystalline size from 18 to 46, as you said, and in surface reference from 5 to 20. The band gap has decreased and the conductivity has decreased, as we have seen. Erbium doped titanium exhibit higher specific capacitance and improved rate capacity or capability, in both basic and acidic electrolytes, so in acidic. Before I go to the goodbye, I would usually say we will see you soon. Hopefully we'll see you soon in Jordan. These are my colleagues from IMT in Bucharest, Christina, Alexandra, and Owana. Our friend who is also a collaborator. The last month we made an MOU with the IMT. Octavian was the one who signed it with our university. As I said in the beginning, Petra is the 7th wonder in the world. If you come to see Jordan, you have to see Petra. My colleagues from you, Anna, she is the dynamic person who always make those kind of, scientific collaboration as well as social collaboration. Gabriela, also, she's from the military academy. She's the first to meet from Romanian colleagues, and she started our collaboration with them. And Aurel was also in the military academy. He's my friend. Gabriela, Anna, and the colleague Mădălina, also they are holding Jordan flags, and you will be hopefully to be with the social activities when you come over. That's part of the social activity with Octavian, with Anna, and others when they visited Jordan. And my colleagues, I have to thank them. This is Qais. Qais is a super person. He is a super scientist. He finished his PhD, did not get his certificate yet, but he has now more than 125 papers or articles. This year he become with me as one of the top 2 persons in the world, as according to the new rates. This is his wife. Also, she's my research assistant. She is my student, also research assistant. And the others, Professor Muhammad Omari. He is the dean of the Nanotechnology Institute, and Muhammad also is the other one. I am between the best couple or companies, Ahmad Ali and Hassan Jarrah. Those are my team in my thin films and nanotechnology laboratory at Jordan University of Science and Technology. I would like to thank you. I'm very sorry about what has happened in the beginning. Thank you. Any questions? Are we there, Anna?